composite number using primes. Like as a new example, 3 times 7 times 11 is 231. These three numbers are prime and thus the only ones that go into 231. From this I can tell you that 231 is divisible by combinations of these primes, like 21 or 77 or 33, but it's not divisible by 13 or 17 or 19 and so on, because like we said, there's only one possible representation. So now if you were asked, like, is 18 factorial divisible by 23, you could immediately say no, because whatever 18 factorial is, it's made up of primes that are all less than 18, like 17 and 13 and 11 and so on. Then any composites such as 15 are simply made up of primes less than that, or 5 and 3 in this case. You won't find a prime greater than 18 in here. And since there's only one way to represent 18 factorial as a multiple of primes, just like any other number, then I can safely say it's not divisible by 23, or 29, or 31, and so on forever. With that background, you now should be okay with this theorem. For any composite number x, one of its prime factors must be less than its own square root. To see why this is true, let's just see what would happen if it wasn't. For example, the square root of 129 is about 11.35. Now let's just say there are two prime factors to this number. The theorem above says one of those must be less than 11.35. Because if that weren't the case and they were both greater than 11.35, like let's say 13, the next prime number up, we've already exceeded 129 when we multiply those. So one of the primes has to be smaller than that square root. In this case, 129 is made up of 43 and 3, which goes with what the theorem says. Now if we take the number 119, the square root of that is about 10.9. Thus, if it is composite, one of its factors must be less than 10.9. And the only primes less than that are 2, 3, 5, and 7. I know 2 and 5 don't go into 119 just by looking at the ones digit, of course. So really I just need to check two numbers. 3 does not go into 119, but 7 does. Thus it's composite, and it only took 2 tries to figure that out. And now if you want, thus it's composite. 3 does not go into 119, but 7 does. Thus it's composite, and it only took 2 tries to figure that out. And now if you wanted to determine whether 901 is prime, you know you only have to check primes less than the square root of that, or about 30. Which is only 10 numbers, or really 8 if you exclude the obviously wrong ones of 2 and 5. But now I want to show you something called wheel math. Okay, not really, it's called modular arithmetic, but I'm going to stick with wheel math to keep this video as visual as possible. First, I'm going to make a wheel of numbers, and to begin it'll have 7 spokes or sections to it, although I could have picked any number I wanted. So let's see what this tells us. The wheel starts at 0 and goes around to 6. It then jumps up to 7 and it continues going around in this spiral. One thing to note is that as we move up some section, we simply are adding 7 each time, which means this section starting at 0 is the numbers divisible by 7 section. Another thing you'll notice is this tells us the remainders when we divide by 7. Like if I have 15 guests over for a party and want to make teams of 7, I can make 2 teams with 1 person left over, aka 1 is the remainder. And if I had 25 friends over, I can make 3 teams of 7, which would leave 4 left over. Any number that's divisible by 7, of course, would have no remainder. By the way, 2 values being in the same section, like 2 and 9, means they're congruent modulo 7. But again, I want to keep this video as visual as possible and hold off on all the official notation. Now, math on this wheel gets interesting. To start off, pick any 2 numbers, let's say 2 and 3. Then add them, and the result will of course be 5. But if we pick any 2 numbers on those same initial sections, like 9 and 17, the sum of 26 will lie on the same final section. And the same thing happens with multiplication. 2 times 3 is of course 6, so something like 9 times 17 must give us something on that same resulting spoke, in this case 153. Then if I add 1 to that, we get 154, taking us to the next spoke over. And now just add us something on that same resulting spoke, in this case 153. Then if I add 1 to that, we get 6, so something like 9 times 17 must give us some same final section. And the same thing happens with multiplication. 2 times 3 is of course 6, so something like 9 times 17 must give us something on that same resulting spoke, in this case 153. Then if I add 1 to that, we get 154, taking us to the next spoke over. And now just by looking, I know that number is divisible by 7 since it's in that divisible by 7 section of the wheel. See, this is where it gets more interesting. Like, since I know that 2 times 3 plus 1 is divisible by 7, I also know, let's say this time, 16 times 24 plus 1 is also divisible by 7. And that's because these sets of numbers all lie in the same Like, since I know that 2 times 3 plus 1 is divisible by 7, I also know, let's say this time, 16 times 24 plus 1 is also divisible by 7. And that's because these sets of numbers all lie in the same section on our 7-spoke wheel. And to continue with the basic arithmetic, this applies to exponents as well. 2 squared is of course 4, and this tells us that anything in this blue section squared will output a number in this green section, where we found the 2 and 4 respectively. So since like 16 squared is 256, I know I'm going to find that number further up this green section. This isn't deep math or anything, by the way. I mean, when we square some number x, it becomes x squared, of course. And when we take a number on that same spoke as x, which would just be the same thing plus some integer multiple of 7, and square that value, after some simplifying, of course, I also know, let's say this time, 16 times 24 plus 1 is also divisible by 7. And that's because these sets of numbers all lie in the same section on our 7-spoke wheel. And to continue with the basic arithmetic, this applies to exponents as well. 2 squared is of course 4, and this tells us that anything in this blue section squared will output a number in this green section, where we found the 2 and 4 respectively. So since like 16 squared is 256, I know I'm going to find that number further up this green section. This isn't deep math or anything, by the way. I mean, when we square some number x, it becomes x squared, of course. And when we take a number on that same spoke as x, which would just be the same thing plus some integer multiple of 7, and square that value, after some simplifying, it just turns into x squared plus an integer multiple of 7. Therefore, it's on the same spoke as x squared from above. And yes, this will work with any integer exponent, by the way. So now take a look at the number 1 on our wheel. Since 1 to any power, I'll just use 26, is itself, or 1, and therefore maps to its own spoke, I know that anything else in that section, like 15, will always map to the exact same section when you include any integer exponent. Thus, I know 15 to the 26, or any other integer exponent, has a remainder of 1 when divided by 7, since it will be in that same section as 1. So now in a matter of seconds, you can answer some seemingly tough questions that you may not have been able to do a minute ago. Like, is 8 to the 167th minus 1 divisible by 7? This is actually really easy to do. I don't know what 8 to the 167th is, but I know 1 to the 167th is 1. Thus, 8 to the 167th will give us a value also in that same section, just higher up. Then when we subtract 1 as the question asked, we move one spoke over and land in the one where all numbers are divisible by 7. So the answer to the original question is yes, with no intensive work required. But here's the least intuitive property I'll discuss, which works since we're using a prime number of spokes, or 7 in this case. Take any number not divisible by 7, like 2, 5, 15, or whatever, and raise it to the 6th power, or 1 less than the number of spokes we have, and that resulting value will always land in the section that has a remainder of 1. This will always be the case with prime wheels. As in, if we had a 5-spoke wheel and took maybe 12 and raised it to the 4th, our prime number minus 1, the resulting value will definitely be in that same section that has 1 as the remainder, just like before. And also, like we saw earlier, we can do fast math and say that 12 to the 4th minus 1 is divisible by 5, because it lands in the divisible by 5 section of this new wheel. This is Fermat's little theorem, again written like this, To break this down, it says that on a wheel with a prime number of sections, any number we'll call A raised to the power of our prime minus 1 will be in the same section as the number 1, so long as A is not divisible by the prime. So when asked something like, what is the remainder when 2 to the 100th is divided by 101, it's actually really easy. Since 101 is prime, then anything that's not a multiple of 101 raised to the 100th, or that prime minus 1, will be in the same section as 1, and thus that will be the remainder. Another cool property that works for any wheel with a prime number of sections is that if you take any number, raise it to that prime power, or 5 in this case, the result will be in the exact same section. And this kind of answers what we saw in the beginning of the video. You'll notice that on any section, every other number has the same ones digit since they're 10 apart. So like all of these numbers are ones that end in 2 or 7. Now we just saw that any number to the 5th stays in its own section on this wheel. So doing that operation either keeps the same ones digit or changes it by 5, such as 2 going to 7 or 7 going to 2. Except when you raise a number to the 5th, odds will stay odd and evens will stay even. Thus this second option isn't possible, and any number to the 5th will retain its ones digit as mentioned in the beginning. Now if we make a wheel of 12 numbers, some cool things come from it. One thing to note is that all the primes show up on only 4 spokes. The only exceptions to this are the numbers 2 and 3, which are the only primes on these 2 right-hand spokes here. Again, this is nothing deep, as with most of this video honestly. It happens simply because the primes that make up 12 are only 2 and 3. So in those sections, as we add 12 and move up our wheel, the resulting numbers will all be divisible by 2 or 3. In fact, all the sectors that consist of composite numbers start with a number divisible by 2, 3, or both. The sectors with primes, on the other hand, all start with a prime number or the number 1. So this isn't groundbreaking or anything, but I find it to be an interesting way to just look at numbers and primes. Then going back, if we multiply 2 primes together besides 2 and 3, the resulting value will also be in the same sections as the primes, just filling in some of the gaps. But the weirdest thing is that any prime number squared besides 2 and 3 will land in this section. This means any prime number squared minus 1 lands in the next spoke over, or the section where everything is divisible by 12. I mentioned this earlier, but an even stronger case where any prime squared minus 1 is divisible by 24. If you want to know why, just note that p squared minus 1 can be written as p minus 1 times p plus 1. And on a number line, we can write p minus 1 and p plus 1 around the original prime p. Now, since p is prime, then it's not even because it's greater than 2, meaning that p minus 1 and p plus 1 are even or divisible by 2. But every other even number is divisible by 4, so either p minus 1 or p plus 1 has a factor of 4. It's easier to see this with examples, like if these numbers were 30, 31, and 32, one of the even numbers must be divisible by 4, which 32 is. Then of 3 numbers in a row, one of them must be divisible by 3. It's not p since p is prime, so it's gotta be one of the others. This means that 2, 3, and 4 are factors of p minus 1 or p plus 1, and those multiply to 24. Thus 24 is a factor of the original number. Now, earlier in the video I talked about dividing a number by 3, and as I'm sure many of you know, when it comes to 9 and 3, divisibility is actually really easy due to a certain rule. The rule is, if the sum of the digits of a number is divisible by 9, then the number itself is divisible by 9, and the same goes with 3. As in, 972 is divisible by 9 because 9 plus 7 plus 2 is 18, which itself is divisible by 9. The reason for this is I can write 972 as 900 plus 70 plus 2, which can break down further to 9 times 100 plus 7 times 10 plus 2. 100 can then be written as 99 plus 1 and 10 as 9 plus 1. Then if I distribute everything, we're left with this. These terms are both divisible by 9 due to the 9 and 99 in them. So in order for the entire number to be divisible by 9, the last terms combined must be, which are the digits of the original number. A slightly more official term for working with 9s though is the digital root. To calculate the digital root of a number, let me just show an example. If we want to find the digital root of 921, let's say, we just add the digits together, giving us 12. We then add those digits together, giving us 3. Once we're down to one digit like this, we have the digital root. The cool thing about this is that it tells us how far a number is from being divisible by 9, aka the remainder. In this case, we see that 921 minus 3 is divisible by 9, which you now also know because of the digit summation. Another property, if we go to Brilliant's site, is that digital roots do not change when you add or remove 9s from a number. So like we saw, 921 has a digital root of 3, yet so does 9,921, and 99,921, and so on. Adding 9s doesn't change anything. Which means this huge number's digital root is 3, and thus it is 3 away from being divisible by 9. And this just comes down to the fact that if we remove all the 9s, leaving us with 21, that's also 3 away from being divisible by 9. Then something even weirder is that digital roots multiply. As in, if you want to know how close this result is to being divisible by 9, you multiply the individual digital roots. Since these 9s don't matter like we just saw, we can remove them. This means the digital root of each number is 1, and thus when we multiply them, the final digital root is, of course, 1. So I don't know what this large value is, but I know if I subtract 1, it will be divisible by 9. And just because we've seen 24 come up in this video in a kind of surprising way, here's another example dealing with digital roots. These are the first 24 numbers of the Fibonacci sequence, if we exclude 0, where you add the two previous numbers to get to the next. And these are the associated digital roots. Strangely, the digital roots you see here repeat this pattern forever as you go through the Fibonacci sequence, reoccurring every 24 numbers. Not going to go into more detail beyond that, but I just found that interesting. Now after all of this, you may be saying, yeah, this can help me do fast math, but can it help me write secret codes? Okay, maybe you weren't thinking that, but still the answer is yes, like I briefly mentioned in the beginning. I've done an entire video on the math behind cryptography, but for those who just want to know how the things we saw here apply to encrypting messages, here's a quick explanation. First, just imagine a world before cryptography where you want to communicate with someone you've never met before, yet there's an eavesdropper in the middle of you two who can hear anything you say or see anything you do. My question is, how would you communicate a message to the other person secretly just by shouting over to them? You can communicate anything, a place to meet, a secret number, a secret phrase, or whatever, but the eavesdropper who can hear everything is not supposed to understand what you said. And assume you all speak the same language and none of you guys know each other. So see what you can come up with. Yeah, it's definitely not easy if you don't have time to communicate beforehand. But here's one thing you can do. Tell the person we'll be doing some math on a wheel with 17 sections, and we're going to pick a base value of 5. I didn't have to pick these numbers, but I'm just using them for simplicity. So yes, you've said this out loud, which means the eavesdropper will be in on everything so far. But then you tell the person to think of a secret number and don't say it out loud while you do the same thing. So let's say they choose 4 and you choose 3. Now you do that base value of 5 to the power of your secret number, which gives us 125, and then you find the smallest number on that section of the wheel. With 17 numbers, 125 will be in the same section as 6, and 6 is what you tell the other person. Then they do the same by calculating 5 to the 4th, which is in the same section as 13 on our wheel, and they tell you that value. So now the eavesdropper has these two values as well, but not the secret numbers. Lastly, you take their value of 13 and raise it to your secret number of 3, and again, find where that is on our wheel, which is 4 in this case. The other person does the same, and they will guaranteed get 4 as well. This number is then your secret key. We haven't shared a message really, but we have established a secret key that we can then use to encrypt messages. For example, now we could shift the letters in our message by 4 to communicate. Although no, that is not what modern cryptography does. What you saw was the basics of the Diffie-Hellman protocol, and the reason it works to establish a secret key is because it is easy to do the math you just saw forwards, but it is very hard for the eavesdropper to take the numbers he has and work backwards to figure out your secret numbers and therefore the final key. Algorithmically, it would just take too long. Not with this example, but when dealing with numbers hundreds of digits long, going forward is doable fairly quickly, Yet going backwards at the moment just isn't feasible in a short amount of time, so you can have a secure form of communication even if someone's watching. Now, everything you saw was really just scratching the surface of this branch of math, but if you found this content interesting, I recommend checking out Brilliant's number theory course where you'll learn a lot more. There you'll be taken through all the basics like you saw here, but they also include interactive exercises and show unique applications of all the underlying math in much more detail. This includes things like analyzing the trajectory of a pool ball on an ideal table, certain dimensions, or how to mathematically solve a number theory puzzle that was famously portrayed in the movie Die Hard 3. On top of number theory, they have differential equations, complex analysis, logic, and over 50 other courses to choose from that all come with practice problems and interactive exercises to ensure you fundamentally understand each concept before moving on. On top of this, they have daily challenges that turn learning into a habit, so you can look forward to learning a range of topics from quantum physics to geometry puzzles and more. So if you want to get started right now and support the channel, you can click the link below or go to brilliant.org/majorprep to get 20% off your annual premium subscription. And with that, I'm going to end that video there. If you guys enjoyed, be sure to like and subscribe. Don't forget to follow me on Twitter and join the Major Prep Facebook group for updates on everything. Hit the bell if you're not being notified, and I'll see you all in the next video.
The rocket equation, it's a beautiful thing. No.
Okay, so those are some of the This video was sponsored by Brilliant. Imagine we have three objects that are all three-dimensional, just floating in space. The objects can look like whatever you want, but they have to be physically possible, so nothing of infinite size or anything like that. The question, or really our goal, is to show that no matter where the objects are, or what they look like, there exists a single plane that cuts them all in half by volume. Now, some of you might say, I've seen something like this before. It was a Numberphile's video on the ham sandwich problem. But here we are going to require a topological proof, and more specifically a topological theorem known as the Borsuk-Ulam theorem to be used in the proof. This is in the spirit of, well, this is how the question is phrased in an algebraic topology book like this one from Hatcher. Don't worry though, no prereqs are needed for this video. I'll explain Borsuk-Ulam in a second, and we don't need to define what a compact set is because by requiring the objects be physically possible and not infinite, they'll be compact. So here's the semi-brief explanation of Borsuk-Ulam. In the simplest case, if you have the unit circle and continuously deform it into the real number line, squish it anywhere into the line without tearing it, then guaranteed there are two antipodal points on the circle, points lying on opposite ends of a diameter, that map to the same point. It doesn't matter what the transformation looks like, no matter how it stretches, folds, or whatever, as long as it doesn't tear, there's gotta be at least one pair of antipodal points that got sent to the exact same spot. Now that's not the case if the transformation looks like this, but this isn't continuous since it involves tearing the circle at the top. You don't have to think of this as a physical transformation though. Say we assign a temperature to every point on the circle, like think of this as a ring with a weird temperature gradient. Then every point is mapped to or assigned a real value, whatever its temperature is. If the temperature here is 20 degrees Celsius, that point gets mapped to x equals 20. And this mapping is continuous, since temperature is continuous. You can't have the temperature just immediately jump from 10 to 20 in no space. Thus, Borsuk-Ulam tells us that on this ring, there are two antipodal points somewhere that must have the same temperature. They map to the same real value. The theorem is more powerful though, because it says this works for any dimension. This was the simplest case when n equals 1, but for n equals 2, it means that if we map the surface of a sphere to the plane continuously, then same thing will happen. Two antipodal points will map to the exact same spot. no matter what the transformation looks like. But we can think of this in a different way just like before. Consider our sphere to not only have a temperature at every point, but a temperature and a pressure, like is the case with the surface of the Earth. Now every point gets mapped to something in the XY plane, representing pressure, temperature. This is also continuous, so Borsuk-Ulam guarantees that there are two antipodal points somewhere that get mapped to the same spot. Meaning that right now there are two antipodal points on Earth somewhere that have the exact same pressure and temperature. Now going back to our original problem, what we're going to do is actually prove something simpler. We're going to go down one dimension and instead use Borsuk-Ulam to prove that for any two objects in a plane, there exists a line that cuts them each in half by area. This is one easier to show visually, but also the analysis pretty much extends up to whatever dimension you want and will allow us to answer the original question. Now, I only have so much room on the screen, so sorry if it gets crowded, but our new goal is to use Borsuk-Ulam and the mapping of a circle to the real number line to prove that the line on the right exists. Thus, we need some way to assign a real number to every point on the circle in a way that actually helps us. Assigning temperatures obviously is not helpful. So the first thing we're going to do is recognize that any point on the circle has a tangent line associated with it. Then this is where we need to get clever. Any tangent line will have some specific slope, and for object 1 I'll call it up here, note that there's only one line with that slope which cuts that object in half, as we can see here. It shouldn't be too tough to see that that line definitely exists. Just imagine the line being up here, where 100% of object 1 is below the line and 0% is above. As we move the line down, those numbers must change continuously, meaning we will reach 50-50 somewhere. So for that slope we have a unique line. But the same thing can be said about object 2 on the bottom, or really any compact 2D shape. So this point on the circle gave us two lines of the same slope. We still need to assign a real number to that point though. And to do it, we're going to take the perpendicular distance between our two lines in a clever way. I'm not using any axes on the right, so let's say I define this distance as 3, doesn't matter. But we can't only use the positive distance, as you'll see soon. So the clever thing we're going to do is go back to our point and draw a normal vector pointing away from the center of the circle. That arrow is parallel to our distance line, and always will be. So we're going to say that if the arrow, when I move it over here, is pointing towards line 1, the one that cuts object 1 in half, which is the case here, then the distance is positive. If the arrow is pointing towards L2, then we define the distance as negative. But here it points at L1, so distance is positive 3, and we have now assigned a real number to this point on the circle. But we can apply this mapping to all points on the circle. I know that was a lot, so let's see it again. Here, we'll do everything for this point this time. The first step was to recognize there is some tangent line there, and that leads to a unique line with that slope, which cuts object 1 in half, and another, also with that same slope, that cuts object 2 in half. For simplicity, we'll say the distance between those is now 4. But since the normal vector at that point on the circle points towards L2 this time, when I move it over here, then that distance is defined as negative. Thus, that point gets mapped to x equals negative 4. Okay, so that's all we're doing. Taking the tangent line slope to cut each object in half, and then we find the distance between those two lines, which can either be positive or negative. And note, this mapping is continuous, because if you slightly wiggle the input point here, move it just a little, the lines change. Just a little as well, and so does the distance. Thus, small changes in the input lead to small changes in the real number output. So, no sudden jumps, which is the unrigorous way of saying the mapping is continuous. Now, to see where Borsuk Ulam comes up, we have to look at where antipodal points map. Because if we take the point directly opposite of the one currently on the screen, then it has the exact same tangent line slope. So the two corresponding lines that cut our shapes in half are the exact same as before. And thus so is the distance almost. Remember that bottom left point mapped to, I'll just say exactly -4. But for that opposite point, the normal vector points in the opposite direction, towards L1 in this case. Meaning we define that distance now as +4. That's where that point gets mapped to. We define that distance now as positive 4. That's where that point gets mapped to. And this will always be the case with antipodal points, due to having the same tangent line slope, but opposite pointing normal vectors. So if one point maps to x, then its opposite must map to negative x, no matter where we are on the circle. But Borsuk-Ulam says there's got to be 2 points somewhere where these map to the exact same point. And the only way for that to happen is if they map to 0. Remember, in general, Borsuk-Ulam just says some antipodal points map to the same real number. It doesn't have to be 0. But because of how we define distance, then there's no way for any pair of antipodal points to both map to like positive 2. One must be the negative of the other. So that match has to happen at x equals 0. And if these points on the circle both map to 0, then that means the distance between the two lines that cut our objects in half is 0. Thus, they're the same line, meaning we found one line that cuts both objects in half. So that's how you prove it in 2 dimensions. But moving up to the 3-dimensional case involves essentially the exact same analysis, so I'll keep it brief. For the next dimension up, Borsuk-Ulam says there exists antipodal points on a sphere that map to the same point in the xy plane. For any point on the sphere, I'll pick the very top for simplicity, there exists a tangent plane this time with some unique slope, or really gradient, as you can see here. And going back to our 3 objects, this then corresponds to 3 planes of that same gradient, which cut each object in half. And we can define 2 distances in this case, between plane 1 and 2, and 2 and 3, or whatever you want to call them. Write those distances as a coordinate, and you have mapped one point on the sphere to a point in the xy plane. Then we can define each individual distance as negative depending on the direction of the normal vector, just like before, meaning that antipodal points always map to negatives of one another. And by bringing in Borsuk-Ulam, we know some pair of antipodal points map to the same spot, and that spot must be 0, 0, the only coordinate that's a negative of itself. So this point also gives us 3 planes of some gradient which cut all our objects in half. However, the 3 planes have no distance between them since this maps to 0, 0. Thus they are the same, a single plane which cuts all objects in half. The theorem tells us nothing about how to find that specific plane, but it does tell us that one exists. So that's about it for this topological proof, but if you like these kinds of puzzles as well as 3D animations, then you can find a lot more over at Brilliant, this video's sponsor. For example, I'm a big fan of their differential equation series because of its emphasis on applications along with animations that help you get the visual intuition needed to truly understand some of these more advanced concepts. Like topics include pursuit curves and the paths traced out by one person chasing another. There's 2D and 3D wave equations, equations that model the behavior of beams, and plenty more. Plus, if you just enjoy solving puzzles, Brilliant has daily challenges that help turn learning into a habit. So if you want to get started right now and support the channel, you can go to brilliant.org/ZachStar or click the link below, and the first 200 people to sign up will get 20% off their annual premium subscription. And with that, I'm going to end that video there. Thanks as always to my supporters on Patreon. Social media links to follow me are down below, and I'll see you guys in the next video.
At Ultra, we know exactly how important even the smallest parts of our universe are. Chemical elements help us in many different ways. They let us grow. They mobilize us. They make materials durable and resistant. They let us build for the future and improve our everyday lives right now. In the center of Germany's most important industrial region, Eltra develops and manufactures elemental analyzers.
This video was sponsored by This video was sponsored by Brilliant. Alright, another one done, so let's go through it. So I just finished going through this textbook on abstract algebra, and this one took me about 5 months to complete. And it's a pretty long book, 33 chapters, nearly 600 pages, and technically at the time of making this video, I'm not totally done with the special topics, but I've learned plenty and needed to make a video. So first, I really like this class, definitely more than Real Analysis, which was the last book I went through, because like the problems didn't take 2 hours to go through each time, and I forgot what that was like to be done with a problem within a few minutes. So that was a nice change. And this class is unique in that I don't really have anything else to compare it to. I mean, it's a math class, there's no physics problems or particle motion or anything like that. But this class does have applications to fields such as physics, chemistry, cryptography, which is talked about in this class, and plenty more. You learn 3 things for the most part. 3 mathematical structures, groups, rings, and fields, which are all related, and they take some time to explain, so I'll do that in a sec. I mentioned before, this class has a lot to do with symmetry, the mathematics of symmetry, and symmetry shows up in physics, chemistry, board games, mathematics itself, and so on. So you kind of get the idea of how it can be so useful. But there's more to it. Now this is a class you're required to take as a math major, but you'll see physics majors and even computer scientists take it as well. I just don't know if those are because it's required or they took it as an optional elective, or maybe it depends on the school, but it's not just for math majors. And you could honestly take this pretty early on in college, I would assume, because there aren't many prereqs. The biggest one I would say was basic proofs. If you're comfortable with direct proofs, proof by contradiction, contrapositive, induction, and if and only if, then you're pretty much covered. I would highly recommend some number theory background though, but you don't need too much. It's just that in abstract algebra, there's a lot of modular arithmetic, and a lot of solutions or theorems, mostly in the beginning of the book, involve the least common multiple or greatest common divisor of some stuff. So if you know, for example, why like this has no integer solutions and why this does in relation to the greatest common divisors, and also how to move things around in this modular arithmetic problem, you probably have enough background. Otherwise, maybe 2 chapters of a number theory book and you're good. Or just watch some YouTube videos. Then linear algebra is the other prereq, but I would argue you actually don't need it for the first 19 chapters of this book. Yes, it shows up, but if you just ignore the linear algebra examples and practice problems, you'll be fine. They only account for maybe 5% of problems, and the other 95% have nothing to do with linear algebra or matrices or anything like that. After chapter 19, you start to generalize vector fields and basis vectors, which they review, but it would be weird to attempt that without a linear algebra background. Okay, let's go for an explanation, and this will not be a deep dive, it will just be a very generic overview. Again, you learn 3 topics: groups, rings, and fields. They are all sets. Like here's a set, the set of integers. Now, in order for a set to be a group, the most broad of the 3, a few criteria have to be met. The main one I'll emphasize is that there has to be some operation, like addition in this case, that allows you to combine 2 elements in your set and get something out that is also in your set. So the set of integers is a group under addition because you can take any 2 integers, combine them with addition, and get a third. There are other reasons this is a group, but not important for this video. Because what is important to note is that groups don't care about what the operation is. Sure, it could be addition or multiplication, but the set of all permutations of, let's say, 3 objects forms a group using the operation of composition, basically applying one shuffle to another. Like applying this shuffle, which switches the first and second position, then this, which switches the second and third position, gives you this, just another permutation still in your set. I know that probably looks weird written out, but all we just did was took the original permutation, swapped the first 2, and then swapped the last 2, and we get another permutation. So for groups, operation doesn't matter. You just can't leave the set with that operation. Rings are just a little stricter. They are also sets, but the operations must be addition, subtraction, and multiplication. It can't be just anything now. So the set of integers is a ring as well. I can take any two elements, apply those three operations, and get another integer. A really big topic discussed in this book is polynomials, and the set of all polynomials with, let's say, integer coefficients also forms a ring. They combine through the three operations and still yield a polynomial with integer coefficients. And this happens a lot in this book, where you analyze polynomials but restrict what their coefficients can be and what can be plugged in. Like, this polynomial can be factored as such, but if you restrict your world to only rational numbers, then this cannot be factored because root 2 is irrational. So we say it's irreducible over the set of rationals. And while that seems strange to do, there are applications, which I'll show in a sec.
I really propose that visualization in multiple views can help you understand data, particularly on cases that people don't understand very well.
We often think about machine learning as this fully automated process. Throughout this talk, I'm going to be arguing for the importance of taking a human-centered view of machine learning.
So at present, people who are blind can take their mobile phone and have that sent off to remote humans who in turn will either return a caption or an answer if a question was provided.
The gaming industry really seems ready for a big disruption with, again, using these reinforcement learning agents to develop better game AI, better developer tools, and so on.
Then lastly, fields are just a little stricter than rings. They are sets that require division on top of the three operations required for a ring. So the four operations we're familiar with since elementary school. Thus, the set of integers is not a field, because although the first three operations work, you cannot take any two integers and divide them and get another integer. The set of rational numbers is a field though, same with the set of real numbers and complex numbers. Now, while there are three main topics, I kind of think of this class as groups, then rings and fields. Although they're related, since groups are much more general, they apply to a lot more, especially outside of math. Again, systems that involve symmetry often have underlying group structures. Rings and fields apply more to areas within math. There are applications within cryptography or coding theory, but the big ones, especially those covered in this book, would be like constructible numbers. If you were only given a straight edge, compass, and a unit length, could you, in theory, draw a line segment that has a length of exactly 1/2, or root 3, and so on, without just guessing? It must be exact. And this is a problem that heavily relies on the knowledge of fields. Or another topic related to fields would be proving there is no, quote, quadratic formula to solve for a 5th degree polynomial or higher. So as you can see, for rings and fields, you're mostly staying within math. Throughout this book, by the way, you really only do math problems. Although I mentioned other applications, don't expect to directly see any. You're just getting the foundations here. And it does get abstract. Like, can you think of any fields with a finite number of elements? I mentioned the rationals, real numbers, and complex numbers, but those are all infinite. However, there's an entire chapter dedicated to finite fields, so yes, they exist. And this is one area where you'd especially need modular arithmetic. And then, for example, you prove how the number of elements in a finite field must be prime or an integer power of a prime. These are the kinds of things you learn. And you can maybe see why number theory is important, with primes also showing up a lot. But it's not just, here are some definitions, now tell me what is a field or a ring and what isn't. Once you get these definitions, there are certain properties that reveal themselves that give you more intuition about what these are and how we can use them. Then something else I want to mention is that I know these seem very random. Like, couldn't anyone just make a definition and call it a ring, a field, a blah, 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 or whatever? Well, yes. But the thing is, it took time for these definitions to become what they are. And they became that way because they kept showing up within mathematics and even in other fields. They're defined how they are because they have proved to be useful. For example, I loved the constructible numbers chapter of this book, which came at the very end, but it put so much together. When I learned about construction in geometry, I found it so boring. Like, I just didn't care that you could cut a line segment in half or an angle in half. But when you look at this through the lens of abstract algebra instead of geometry, I found it to be really interesting. Because note that if two lengths are constructible, you can make them with a compass, ruler, and a unit length of 1. Then so is their sum. Just start the second length at the end of the first, and you get a plus b. But their difference is also constructible by going the other direction. Here's a minus b. And then using some clever triangle tricks, which you can do using a compass, it turns out the product and quotient of the two are also constructible. So if you're given a unit length of 1, then 1 is constructible, obviously, but so is 2 and 3 and all integers. But now you know so is 1/2, 1/3, and so on because quotients are possible. But how far can we take this? Like, is root 7 or pi squared constructible? Well, whatever the set of constructible numbers is, we don't know at first, we do know that take any two, you can apply these 4 operations and get something else in the set. Thus, the set of constructible numbers is a field. More specifically, it's a field that includes all rational numbers, but I will say not all real numbers. Pi is not constructible, but root 2 is as such. So we have a field in between the rationals and reals. And if you haven't had any exposure to this class, it might be tricky to think of any field in between the rationals and reals. And amazingly, finding that field has to do with finding solutions to polynomials that have only rational coefficients and a degree of some power of 2. I'm not going into depth here, as I hope this kind of creates some interest and maybe for some people some fear, but don't worry, you start at the very basics. And I mentioned this because if earlier you asked why would we care about polynomials that just have integers or rational numbers as coefficients, why would we need to restrict our world to some specific set like that? Well, here you go. It actually has applications. Having a rigorous foundation of polynomial rings via abstract algebra allows us to gain a fundamental understanding of a construction, a topic that you would think is purely geometric, but in fact is not. I'm also going through an algebraic topology book right now, which takes topology and abstract surfaces and combines it with groups. So abstract algebra is a prereq. And very quickly learn how loops on a surface have a group structure, where the operation is concatenation. Like if I gave you 2 loops, one loop and then another loop, and put them together by like just doing one then the other, technically you still have a loop because you start some spot and end at that same spot. So that's a loop. And thus you still get something in your set, the set of all possible loops. So you have this group structure, and you can use that to prove certain topological theorems that are very visual, like Borsig-Ulam, the theorem that says there are 2 points on Earth right now that are directly opposite of one another somewhere that have the same temperature and pressure. You can also use this to prove certain fixed point theorems. So there's some cool applications there, and that's one of the big reasons I wanted to go through abstract algebra, is because it's a prereq for some of those more advanced classes. And I personally find it really interesting to see 2 seemingly different subjects come together so nicely. Then in terms of difficulty, I honestly found this to be somewhere in the middle of the math classes I've taken. I don't even know how to make comparisons, but it wasn't the easiest and it wasn't the hardest. I never found myself like stuck on one specific section for weeks or anything like that. I didn't need any extra resources. I just had the book and I'd go through practice problems, reference the theorems back when I needed, and that was all I was really required to really learn the material. Some problems could be done in 1 minute, others took 10, and occasionally I had to take like an hour or 2 to figure something out. But those longer problems definitely were the exception, not the rule. So I think that's about it. If you're going to go into this class soon at university, I'd say honestly brush up on some basic number theory, if anything. Otherwise, you're likely good to go. And I'll put a link in the description to the textbook that I used. It seemed like a pretty standard one used in university. And if you'd like to get an introduction to abstract algebra that's less rigorous and more focused on applications, there is a group theory course available on Brilliant that offers exactly that. Honestly, this is a great supplement even if you do go through the textbook, because this course shows several applications that are not covered in the book, which give you more appreciation for what groups can do. For example, you see how looking at the group structure of different games reveals possible ending configurations. Notice again the symmetry of these boards, which is a good indicator that groups are somewhere to be found. I mentioned permutations before, but they dive further by taking a brief look at how groups apply to permutations and the mathematics of a Rubik's Cube. But the course does begin with the basics, just like a textbook. You start at geometric symmetries, how we can use rotations and reflections to form a group for different shapes. And it goes all the way to some more advanced topics, which dive more into the pure mathematics within group theory. So if you want to get started right now and support the channel, then go to brilliant.org/ZachStar or click the link below, and the first 200 people to sign up will get 20% off their annual premium subscription. And with that, gonna end that video there. Thanks as always to my supporters on Patreon. Social media links to follow me are down below, and I'll see you guys in the next video.
Everyone wants to make an impact, a serious, lasting impact which shakes the ground beneath our feet, an impact which cuts through the mix, grabs people's attention, holds that attention, and then informs, educates, motivates, and converts. To make this impact, today's business professionals reach for PowerPoint. The power of the written word, charts and graphs. Well, okay. Charts are cool, but dynamic charts and video are better. The point is, video is what's captivating you right now. Video is the new deck, the new bullet point, the new...
I'm just a little confused on all of them. Okay, let's see. Alright, for number one, we can just complete the square. Do you know how to complete the square? That's the one with like 4 sides, right? Okay, gonna take that as a no, but you know what? We can just factor it. You know how to factor? Yes, my uncle has one on his farm. Okay, that's a tractor. Did I get it right? Not even close. Okay. Do you know what a polynomial is? Yes, it's when you're hooking up with multiple chicks at the same time. Oh my god. Okay, question. Let's say something costs $5 and I give you a 10. How would you then make change? I'd sign an online petition. Did not see that coming. Okay, do you know what numbers are? Yes, there are 26. Okay, those are letters. But letters are numbers, right? No. But my teacher once said X is 2. Yeah, that was one specific example where the unknown X was 2, but that's not always the case. But 2 plus 2 is 4. Yes. And that doesn't change. No. Looks like your story's kind of falling apart there. I do not get paid enough for this. This video is brought to you by the newly launched STEM merch store. More on that and some of the products we have after the skit. Okay, we got this here. Everyone else have a test? We all good? Okay, you guys have exactly 1 hour to finish. You can begin now. Sketch the Locus diagram for a feedback system having an open loop transfer function of sketch the Locus diagram. Feedback system now being compensated with introduction to the forward path leading compensated with transfer function of explain the effect. Beep, 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 boop, beep, beep, boop, beep, beep. Hey, I'm so sorry. Do you think it'd be possible for you to shut the f up? Thank you. This is a blank canvas. Oh, I can easily fit this equation here. You know, if I kind of wind the equation through the gaps, it totally fits. Okay, not even in this class, but better put some of these equations on here just in case. Never seen that before. Better put it on the note card. Should I put F equals MA on here? I mean, I know it by heart, but I might forget it for some reason during the test. Better put it on the note card. This is gonna be so easy to read on test day. Should I put Schrodinger's equation on the cheat sheet for our dynamics final? No, you don't need to know Schrodinger's equation for dynamics. I'm gonna put Schrodinger's equation on the cheat sheet for our dynamics final. Oh, me. Yeah, so would that circuit have been used in Iron Man's suit? Like in that one scene where he was all like, pew, pew, pew. Then the goop lady was all like, oh no, help me. And he was all like, pew, pew, pew. Yeah, would that circuit have been used there? So would the net force on the center beam still be 0 if the bridge were at the center of a black hole? How do you solve Navier-Stokes? I could use $1 million. So could planes still fly if wind only moved through the 4th dimension? So you guys have any questions? Oh, me. Maybe someone in the back of the room? Right. Yes, what? How does a phone work? F***ing magic! Oh, look at that, we're out of time. Well, I'll see you guys on Monday. So how'd you do it? I don't know. I guess I just got lucky. Okay, let's look at the facts. Let's look at the facts. After the midterm, I find you in the dorm, ask you how you think you did. You say, and I quote, "Dude did so bad, would be lucky if I got even one question right. Honestly, didn't even study for that test." Then you pull the highest grade in the class. Now, how do you explain that? Maybe this stuff just comes naturally to me or something. Oh, yeah. Root locust plots, they just come naturally to you, right? Do you think anyone's gonna buy that? I think a jury of my peers will understand. Your peers f***ing hate you, bro. I got 12 angry men ready to beat the shit out of you because they actually studied for their test and barely passed with the curve that you ruined. Yeah, so I've been interning at NASA since I was 3. So yeah, while you were coding Hello World, I was an intern coding Hello World of Warcraft, right? I mean, like, that was me. What are you doing for your final lab project? I'm not sure. I was thinking of maybe, dude, that's so cool. Oh, what am I working on? Well, I think I want to make like a drone that's a sensor on it that can see through walls. And there'll also be a lightsaber attached to it. So like, yeah. Sorry, what were you working on again? Right, yeah, I was gonna design something either on the... Not even listening. So I think I'm gonna be able to sell my drone to Boeing when I'm done with it, and then I'll use that money to buy Boeing. But, yeah, your project sounds cool. I'd say finishing 2 programming assignments in one night is the closest I've been to a threesome. I asked if you were done on the computer. In fact, I programmed Hello World before I could say Hello World. But I mean, like, hey, you're catching up. I'm just saying, if you use a lookup table, you're a bitch. Oh my god. Yeah, I heard you. Now for the last time, what do you want on your pizza? Alright, you take that one. I think we're good. Everyone has a test? Yes? Okay, perfect. Now note for number 3, where you have to solve for the equation of motion for the pendulum spring system. I want you guys using Schrodinger's equation for that one. Are you serious? Yeah, that was a surprise I was talking about earlier. Alright, big fun. Oh, shut up. Told you. Beep. Okay. Hope you guys enjoyed that one. Before we go, 2 things I want to say. One, if you'd like to get yourself some of the merch you saw in this video, from the clothing to the Mandelbrot phone case to other fractal designs, the engineering clock, some math and science toys, and more, then go check out the newly launched STEM merch store. This is a business collaboration I'm doing with Flammable Maths. We've been working on the website for several weeks now. So check out the link below to look through all the products and merchandise that we have there. And then 2, if you like these skits, be sure to check out my second channel, which is also linked below. Otherwise, thanks for watching, and I'll see you guys in the next video. Would be lucky if I got even one right. Honestly, didn't even study for that test. Damn it. Oh my god. Yeah, I heard you. Now for the last time, what on your pizza is what I was trying to say there. I'm just saying, if you use a lookup table, you're a bitch. So stupid.
You might hate me for saying this, but she's not too busy to text you back. She just doesn't want to. She doesn't want to because you're too obvious, you're too easy, you're trying too hard, and it makes you seem lame and boring, even though you were anything but. Look, I bet she seemed really into you at first, right? But then she started pulling away, didn't she? And her responses started taking longer, her texts started getting shorter, and "I can't wait to see you" turned into "sorry, I'm so busy right now." Let's cut the crap. You know I'm too busy is a lie, right? Everyone knows. If she really wanted you, she wouldn't be busy. She would make time for you. You want to know the real reason she pulled away and stopped talking to you? It's got nothing to do with your height, your looks, or your confidence. She pulled away because you were too easy, too much of a sure thing. She knew she could have you anytime she wanted. And to a pretty girl, that makes you about as attractive as her brother or her gay best friend. So what are you supposed to do? I'll tell you right now. You know that girl you've been thinking about? The truth is, she doesn't actually want you to be sweet to her or compliment her, demonstrate your value, try to make her laugh, or anything else you're doing to pursue her and try to win her over. She doesn't want you to chase her like that. Not even close. In fact, she wants to be the one chasing you. That's what actually turns her on and makes her want you, is more than just a friend. You got to learn to keep her on her toes a little bit. So instead of getting bored and pulling away, now she's daydreaming about you at work, thinking about you nonstop, maybe even texting you late at night to make sure you're thinking about her too. Asking if she can see you soon, ignoring every other guy in her DMs, shooting a shot, making it painfully obvious she wants you and she's all yours. Wouldn't you like to know what it feels like to have a girl chasing you like that? Don't you wish she would stop what she's doing and text you back right away because you are her number one priority? Aren't you tired of freaking losing? If you're saying yes to any of that, then I want you to pause YouTube for a moment and go watch the special training for men only at the link you see on your screen right now. It's a super short video packed with valuable tips that can help you out right away, including the number one female turn-on that makes her want you over other guys. This one thing matters more than your looks, height, age, weight, social status, money, or any other superficial thing that really doesn't matter as much as you've been told. Don't worry, this is not a rehash of anything you've heard before. It's not about being a good listener or using corny lines, and it's not about becoming a self-absorbed PUA or a douchey jerk who treats women like crap. You're about to discover the real psychology of attraction that no one's ever told you before, and how to use it in normal, everyday conversation to have that girl you've been thinking about start to think about you. You'll also discover the most pathetic 5-word question you should never ask a woman you're attracted to, and one innocent F-word you can drop in conversation to guarantee she sees you as a guy she wants to date instead of a friend she feels sorry for. All you have to do is use these innocent secrets in normal, everyday conversation, and she'll be 3 times as likely to start hitting on you out of nowhere, 3 times as likely to ask for your number, and 3 times as likely to make the first move on you and even go home with you that same night. And there's a lot more. Just click the link on your screen to watch the video and get started with your training. A few guys have already told me the first 5 minutes of this video changed the way they view women forever. But I have to warn you, the secret revealed in this video is controversial. It might make you angry. It might challenge some beliefs you have about women and what they actually respond to in a guy. And it will definitely piss off a lot of girls. Girls who really don't want you to have this much power over them. But I promise, if you can just pause YouTube for a second and take a few minutes to see if this video is worth your time, it's going to blow your mind and change the way women see you forever. You'll be able to use these secrets right away on the very next girl you talk to. Maybe even a girl you're thinking about right now. Oh, and just so you know, there's nothing weird or awkward being taught in this video. It's actually very slick. I'm surprised you haven't clicked the button already. So go ahead, click the link and go watch the video right now, before the PC police find out about this and I'm forced to take it down. You may start to feel sorry for other guys after you see how well this works. I often do. Click the link on your screen to watch the video now.
Okay, so Zach, am I pronouncing that correctly? Yeah. Now I see here under programming languages you put Python. Did you put that because you heard about it once in passing or because you're an expert? Well, neither. I don't follow. I mean, I took one intro to Python programming course that was probably 4 months long, I would say.
Oh,
but
4 months? That's 8 years.
Okay, so you're very well qualified. We could use you for some of our more advanced projects. No, I really only know the basics. Honestly, a lot of people here really don't know how to use Python, but since you've been using it for 40 years, we could definitely start training.
Okay, I don't think
better.
you're really understanding me.
Okay, so you listed Microsoft Excel. How experienced would you say you are with that? I mean, I've used it before, so I put it on my resume. Okay, wow, so you're a pro.
No, okay, I don't think you're totally hearing...
See, the thing about me is I can recognize confidence and expertise, so... I got you. I'm picking up what you're putting down.
Don't think you are.
Honestly, we don't use Excel that much, and by that I mean that's all you'll be doing. But since we have the creator of Microsoft Excel in the building, I think we can put it to good use. And just to prove your expertise, I'm going to need you to hack the Pentagon using only Microsoft Excel on the cell phone. And don't worry, you'll have plenty of time, because you get till I finish eating this peanut. Like I was saying, I really don't have that much experience. You're done? Okay, I want you to tell me why... Oh, I don't know. What's it gonna be? And... why we should hire you over everyone else. Wow, that is a fun one. Alright, and commence sounding like a cocky douchebag now. If you had to pick, what would you say your biggest weakness is? And then after you answer that, tell me, why should we hire you when we don't hire the weak? Where do you see yourself in 10 minutes? So what's with this 20-year gap in your work history?
Well, I was born, and then it was pretty tough to get a job for a while after that.
Well, okay, I'll overlook that for now, but if you do get hired, we're gonna need more of a go-getter attitude. What would you do if you caught someone stealing a pencil from work? Well, if it's just a pencil, I probably wouldn't do much. Okay, so you're cool with crime as long as it's something small.
Fine, I guess I would tell my manager.
Oh, you're a snitch! Hey guys, he said he would snitch on the pencil question.
What?
Seriously?
Over
Hey
a
man,
pencil?
look, I've got a pen. Don't call the cops. Yeah, hey, don't worry about them. You're doing fine. What do you hope to accomplish in the first 30 days of this job?
2 paychecks.
And do you have any questions for me?
Yeah, so if I'm hired, what kind of stuff will I be doing specifically?
Oh yeah, if you're hired here, you will definitely be doing specific stuff. And things. In fact, have you seen videos of those futuristic robots doing parkour and all that?
Yeah.
Me too! Aren't those cool? God, it'd be fun to work on those. Oh, and when are you available to start? Wait. It says you have no internship experience. Well, how do you expect to get a job if you've never had a job? Okay, so you have listed a few programming languages here, But I'm going to fire off just some others that we also use and require some proficiency in. So as I list them, just let me know if you've heard it. Starting with basic.
Basic.
Java, JavaScript, Ruby, PHP, HTML, CSS, C, C++, C Sharp, D Sharp, G Flat, Ascending C natural minor scale, Beethoven Symphony No. 9 in D minor.
Okay, isn't that music?
Yeah, that is what most amateur programmers say. No, Beethoven Symphony No. 9 in D minor is actually a new and pretty exciting programming language we use here. That's okay, we'll just keep going. What about say can use C++? Maybe Fortran? 5tran? My infinite loop will go on. 2 girls, 1 compiler? Knick-knack, patty-whack, give that dog some code? You've never programmed in can't stop, won't stop, can't you see it's we who own the night script? Stacy's syntax has got it going on. I wish that I had Jesse's GitHub profile. We're gonna need a bigger terminal. Linux, I am your father? You've seriously never programmed in... No. Okay, well, I guess just because every other applicant has heard of all of those and you haven't, doesn't mean we won't hire you, so let's just keep going. Okay, now these next questions are a little strange, but we ask them and just answer the best you can. Alright, so let's say you're shrunken down to the size of a nickel and thrown into a blender.
Oh, okay. Well, I guess I would try to...
And then you get duct taped to that blender, which is then vacuum sealed from up top and put into a rocket that's on autopilot going towards a black hole, all while acid is filling up from the bottom of that blender. So to recap, the rocket's all like... And then you're all like, oh no, but I'm stuck in the blender. Oh, but the acid, and it's got pulp, gross. We like to see how you handle tough situations. Alright, under hardware you put oscilloscope. Did you invent it?
No.
Oh, just wasn't sure why you put it there. Maybe you should be specific. Oh my god. Now, on top of what you put here, we have some hardware you should be decently familiar with, so I'm just going to fire off some of their names. You let me know when you hear one you're familiar with. Sound good?
Oh, please don't.
Okay, have you used a Waka Flocka spectrum analyzer? What about a shake and bake backhoe? Thor's hammer hydraulic press? A Dunkin' Donuts double oven? How about a baby back ball peen hammer? A Vicks VapoRub vacuum? A Captain Crunch current clamp? Have you calibrated a Duyo chain hang low sensor? It's the one that measures the distance from the floor to your chain in yoctometers.
Oh, yeah, I have used that one.
Oh, dude, that's like all we use here.
Really?
Oh, yeah, you are very well qualified. In fact, you know what? I think there's nothing else. I think we're good here. I'm gonna go talk to some of the other guys, and we'll let you know our decision in like a week.
Okay, awesome. And whether or not I got the job, will you guys let me know either way?
Yeah, either way, we're gonna let you know, but it's looking promising. So it was nice meeting you, and we'll talk real soon. Hello?
Hey, you didn't get the job.
Yeah, I figured. Yeah, we just decided to go a different direction, but I just want to say no hard feelings. As you may have heard, there were several layoffs at the company recently.
Yeah, you unemployed thousands.
Ah, but it was random and fair. See, all these students are coming in thinking if they just know a little calculus, they're qualified to work here. But you see, this company's finite, and its budget is finite. But now our checkbook is balanced, as all things should be.
I mean, do you know how many resumes I had to go through? Don't care. 14,605,000. You know how many people we got to pick? 1. Still don't care. But hey, if you're still looking, I'm happy to pass your resume around. You know, after losing several of my friends and my fiance, I'm not too worried about having a job right now. Wait, you were gonna get married? Yeah. Did I just not see the invitation? You weren't invited. What? I thought we were boys. No. I mean, we shared some pretty intimate stuff that day. No, we didn't. Okay, maybe you don't remember, but I definitely do. The day started with you telling me a little something about yourself. You told me your future goals. You told me not only your strengths, but your weaknesses. You were vulnerable with me. Oh, you told me that sad story about that angry or irate customer you had to deal with, and 3 things you did to resolve it. None of that was by choice. Honestly, I kind of like the idea of you being my employee. With benefits. Are you done? All the applicants love a big benefits package. Uh-huh. You know, I never told anyone this, but I always felt like I was duct taped to a blender of loneliness. And you were the first one to give me tangible advice to get out of that blender. That was the stupidest thing I've ever heard. And sure, maybe I did interview other people after you walked out, but I was just being shallow, judging people by how their resumes looked and not how they made me feel. What can I say? I'm a guy who likes a nice pair of titled columns to separate work from school experience, but that's the old me. Okay, that's funny. Right? You know, when I was younger, I could walk onto just any college campus, even in my work attire, and there would be a line of men and women literally waiting to talk to me. That was the career fair. But things change, people change. Can't go back, but we'll always have the memories. Do you even know how you're going to end this video? Don't do it.
This attempt at humor was sponsored by Brilliant.
Okay guys, we are going to continue with limits today, and although you won't need to know for the test how to construct an epsilon proof for a limit, I'm still going to show you one little example.
Sorry, what was that noise you just made?
Do you mean the word proof?
Yeah, there it is again. What is that? Oh, is that the German word for lookup table? It's like an inside joke he does? Oh, that's funny. This teacher's got jokes.
Zach, I literally asked for the proof that the square root of 2 is irrational, which we covered in its completeness in class already. And you wrote absolute nonsense.
Yeah, wasn't totally paying attention that day. However, I decided to go a different route. Instead of proving that root 2 is irrational, which I mean everyone does, I proved that root 4 is 2. Though proof by calculators, the experts call it. And I think, just to check. Yeah, I got that right. So if you could just put a little A by the top of my paper, that would be great.
What the action? Zach, for this proof, you simply rewrote my question and put a QED under it?
Well, I thought that was trivial and left it as an exercise for the grader.
No, it definitely does not work like this.
Oh, yeah. The meme comes alive. So what are the applications of this? How does this affect me? How do I profit from this tomorrow? If this is not going to affect my daily life, I don't know why I'm here. You gotta throw me some applications. 10 real-world applications I can use in my life tonight, go. Why are we learning this? What's that symbol on the top left there?
X?
Okay, great. And what are its applications? Or just like the first 20 that come to mind? Can you repeat everything you just said over the past 8 weeks? I didn't catch that.
Now, if you really want an A on this exam, you need to show all your work.
Okay.
But if you only want a C, then...
Okay, now we're talking. You said we could still get a C if we show partial work, so just how partial we talking here?
Roughly 70 to 80%.
Yeah, that makes sense.
Wait, but why would she even try to go for a C in the first place?
I'm sorry, what? I am not getting this. What are you working on? I'm at, the hardest part of Calc 2, and I can't figure this out. Which part? The part where you have to calculate what you need on the final to still pass this class. Now, okay, I think I'm getting somewhere though. Because, alright, quizzes are worth 20% of our grade, right? But he hasn't put in the final 2 quizzes we took. And he drops your lowest quiz. I just don't know if it's going to be one of those 2. So, okay, you know what? We can run a comparison test. Yeah, different scenarios, compare different scenarios. So, scenario A, let's say my lowest quiz is not one of those 2. Alright, so that means it would be quiz number 3. Quiz 3, okay. So that means we can cancel out quiz 3. That's gone, okay. And then that gives me an upper and lower bound on the efforts I have to put into studying, right? And then, okay, we're trying to maximize the final grade to effort ratio. Now, if I can, but he curves the final exam. And it depends on how everyone else does. So if I want to optimize this, and I have that many unknowns, can you even do that? Dude, why don't you just use this time to actually study for the exam? Wow, I am not in the mood for jokes right now. Dear Calc 2 gods, please let this final make a little bit of sense. Here we go. What the is that? Why the hell does everyone look like they know what they're doing? Oh my god, 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 oh my god. Maybe I can know, or would this be? I don't know. Holy crap, this curve better be amazing. Everyone just needs to do terrible. Let's see, how confident does everybody look? Okay, this guy knows what he's doing. I gotta stop him somehow. Dude, I'm so sorry. I'm such a klutz. What the hell? Shh. I'm taking a test.
Eyes on your own paper.
Yeah, you keep saying that. Is that required or is that like an optional thing?
Sick. I can see you cheating.
Yeah, we'll prove it. Rigorously. Oh, I think I got it. If I can manage to get 8 out of 10 points on this question, then that'll make up for the 2 points I'll try to BS on this question, and then I'll be good.
So, 30 seconds left, you guys.
Converges, diverges, converges, 7, 3, pi over 4. Like, finally just give me my diploma. Hey, if they made a movie about that test, it'd be called Easy A. Am I right?
Sick? You got a C.
Gotta see the 100% I got? Yeah, no surprise.
Yeah, really an F without a curve, but we will chat later.
Yes, guys, let's get an F in the chat for the curve that I ruined. Good call, Professor. Alright, now I gotta see this thing. Let me check it out. Or just show me the answer key, same test, am I right? What the fuck? Thank you to Brilliant for sponsoring this video. If you want your next test to go as buttery smooth as that transition, check out Brilliant.org, an educational platform that hosts dozens of courses in math, science, and engineering. For the engineers out there who want to not cry as much in math class, I recommend their advanced math courses including multivariable calculus, differential equations, vector calculus, and more, which cover a range of applied math concepts useful in a variety of fields. What I like is that they teach you the technical information through visual animations and real-world examples as much as possible to make sure you really understand even the more advanced concepts. Additionally, you can inspire others and encourage lifelong learning by gifting a Brilliant Premium subscription. If you'd like to get started right now and support the channel, go to brilliant.org/majorprep. And the first... Okay, so...
right?
One of the great challenges in this world is knowing enough about a subject to think you're right.
85% of adults have drank alcohol in their life. It's an extremely popular drug that decreases specific neuronal excitation in your brain with biological byproducts that have a huge impact on your body. So if you're wanting to partake in a bevy, short for beverage, is there an ideal time for your physiology? Is it better to day drink or drink at night?
When you drink a shot of vodka, 20% of the alcohol is absorbed by the stomach, 80% in the small intestine, where it goes into your bloodstream, then to your liver to be metabolized. Ethanol gets into cells by passive diffusion, so the more you drink, the faster you get drunk. And when alcohol accumulates and finally gets to your brain, it suppresses the excitatory neurotransmitter glutamate, which causes information transfer in the brain to become slower, with only the largest signals making it through. You feel less, perceive less, notice less, and remember less. So a check for drinking at night is that day drinking alcohol won't allow you to complete your daily tasks.
A check for day drinking is that we've been doing it for millions of years. Known as the drunk monkey hypothesis, the only reason you're able to drink alcohol right now dates back to a gene mutation that occurred 10 million years ago in your ancestors. A monkey-looking eutherian mammal, which is the common ancestor to you and the chimpanzee, of course, had a mutation in their enzyme, alcohol dehydrogenase, which made this enzyme 40 times more effective at metabolizing alcohol. This specific mutation in the alcohol dehydrogenase meant that no longer would small amounts of alcohol be poisonous, but now could be a viable energy source. This hypothesis also recognizes that around 10 million years ago was when our common ancestors stopped living in the trees and began living on the ground. This new mutated alcohol metabolizing enzyme was beneficial as it made the copious amounts of fermenting fruit on the forest floor accessible as a new dietary niche. Essentially, mutations sound bad, but sometimes they allow us humans to get absolutely sloshed, bruh. And our ancestors were likely eating these fermented fruits during the day. They were also getting lots of new energy. But while drinking alcohol may increase your caloric energy, and while day drinking you might be like kinda giddy, like shots on the patio energy, like woohoo, that will quickly go away and you will become a lethargic afternoon mess, which kind of creates a check for drinking at night. Any excited extroversion you feel while drinking is due to the suppression of brain firing in the prefrontal cortex. This part of your brain controls your impulses and restrains behavior. Therefore, alcohol suppressing this inhibitory part of your brain causes you to loosen up and become a bit more extroverted. For example, once while drunk, I became very extroverted and invited everyone in my university residence into my tiny room to have a dance party. And while blasting Kesha's "This place about to blow," the floor almost caved in, the cops were called, and I was fined for having an illegal rave. Ding! But this drunk extroversion won't last long due to your liver. In your liver is where the famous enzyme alcohol dehydrogenase lives, and it breaks down the ethanol into acetaldehyde. The buildup of acetaldehyde causes incoordination, memory problems, and sleepiness. So day drinking leads to these byproducts building up in your body during the day, causing you to lose coordination, forget things, and become sedated. In fact, drinking during the day is related to higher injuries in sports, which seems a little obvious. All of this is a check for drinking at night.
Perhaps the biggest point for day drinking, or rather the point against night drinking, is that it negatively affects your sleep. Since we now know that alcohol inhibits the excitatory neurotransmitter glutamate, when alcohol leaves your system, the brain kind of overcorrects and there's a rebound of glutamate, which leads to excitability and irritation. Drinking at night means this excitable rebound happens when you're trying to sleep. This ends up dismantling your sleep through the night, cutting it up into tiny little bits and actually interrupting your sleep cycle in a way that a lot of people don't even realize is happening. But you may be saying, but alcohol helps me get to sleep. But electrical brainwaves show that sleeping while intoxicated is not natural sleep. It's more sedative, similar to anesthesia. In fact, alcohol is one of the strongest sedatives of the integral REM sleep, the type of sleep which causes dreams. When the liver metabolizes alcohol, it produces ketones and aldehydes. The aldehydes block the brainwaves needed to generate this powerful REM dream sleep, which can have astounding effects. REM sleep is so essential for a lot of functions in your body and brain, including memory and association. One study got a group of college students together to study them for a week. On day one, they learned a novel computer programming language or a new form of algebra. By the end of day one, they were tested and all had a proficiency of understanding around 90%. Over the coming week, a control group slept naturally, a second group got a little drunk every night before bed on 2 to 3 shots of vodka, which was based on their body weight, and a third group slept naturally on day 1 to 2 and then had alcohol before bed starting on day 3. 7 days later, and they were all tested again. People in the control group without alcohol at night remembered everything they had learned and showed enhanced abstraction and retention of knowledge. The group who drank before bed since day 1 forgot more than 50% of their knowledge, and the group that started drinking after day 2 forgot around 40% of their knowledge. So day drinking actually allows your body enough time to metabolize the alcohol so you can get a good sleep. A check for day drinking for sure.
Some people argue that day drinking a mimosa with the sweethearts or knocking back a cold brewski with the boys makes them feel better than having a dark whiskey on the rocks at night while talking about philosophy. But does the type of alcohol that you're drinking affect how you enjoy it? One survey found individuals reported higher negative expectancies after drinking shots of distilled spirits and higher positive expectancies after drinking wine and beer. Another study found that 29.8% of respondents reported feeling aggressive when drinking spirits. Spirits is such a weird word for a type of alcohol. There is no physiological evidence that the type of alcohol you are drinking affects your mood. But instead, it's how you perceive the alcohol will affect you that affects you. A really important thing is your mood prior to starting to drink. It will be exacerbated by the effects of the alcohol. So for example, if you are day drinking on a Sunday and extremely anxious about having to work on the Monday, you're not going to enjoy your time. Whereas if it's a Friday night, you're kicked back, you're done work, and you're having a brew, that's going to be a bit more fun.
An iconic check for day drinking is that it usually means you'll be getting to eat a meal, and who doesn't want to eat more food? Food plays a huge role in how alcohol is absorbed. If you have food in your stomach, it absorbs some of the alcohol instead of going directly into the bloodstream and physically slows it from reaching the small intestine, where with its large surface area, a lot of alcohol is absorbed very quickly. So day drinking with food means you get drunk less fast.
But in the end, alcohol is like a pretty physiologically disgusting, dangerous, and quite addictive drug. Excessive chronic alcohol intake leads to neurological disorders, cardiovascular disorders, liver disease, cancer, etc. If you want to remember things, perceive the world around you, be coordinated, get a good night's sleep, you're gonna have to skip alcohol altogether.
If I had to choose one, I'm kind of stumped because I don't love day drinking because I feel gross, but I care so much about my sleep that I don't like drinking at night knowing it's going to mess everything up.
Sounds like you shouldn't drink at all.
Yeah, like maybe I just need to stop drinking.
I don't really like drinking, period. It's kind of, it makes me, want to cry. But I do find that if I see people on a patio drinking during the day, I'm like, ooh, I want to do that. That feels fun. And then when I'm doing it, I'm like, is this even fun? I think it's like FOMO, what makes me want to day drink.
If you want to watch us get intoxicated and talk on our podcast about alcohol even more, we'll put links on the screen or in the description below.
Make sure you're subscribed, and we will see you in a few weeks for a new science video.
Peace.
Entrepreneurship and innovation and technology is driving the world right now. You cannot make the difference in the world right now without innovation and without customer centricity. In terms of PMI, we are transforming our business. What we do is try to infuse the entrepreneurship elements in the organization, which is something challenging, you know, in a well-structured company to put these elements to our employees and make the difference to consumers. I think this will be key for the coming period for all businesses that they would like to be successful. In Bulgaria, there are a lot of elements that can support entrepreneurship. If Bulgaria continue building, I'm positive.
България наистина има шанс да стане център за развитие на икономиката и предприемачеството в Европа. Специалистите, които имаме в България, са достатъчно големи професионалисти, за да станат лидерите в други страни в Европа и света. Ние в България имаме една дългогодишна програма за стажанти, която е началото на много хора, развили се в компанията. Това е стажантската ни програма, която преминава през различни отдели и така всеки един от младите таланти, които назначаваме, опознава компанията, опознава процесите, опознава начина на работа и културата на компанията и след това изключително бързо може да стартира работа. Това се случва с голяма част от нашите стажанти, които стават бъдещи лидери в нашата компания.
Предприемачеството трябва да бъде окуражавано. Ние подпомагаме много такива.
Right now, 55 million Americans use marijuana. And in Canada, marijuana dispensaries are popping up everywhere like they're Tim Hortons for weed. And I in Toronto can even order these whittled THC drinks delivered to my front door from the Canadian government. Thanks, Justin. Weed is being pitched to us as kind of amazing, right? Well, a recent survey found that 4.3% of Americans have tried to quit marijuana at least 6 times and failed. Plus, now withdrawal symptoms are being fully understood. So today we are going to explain exactly what happens to your body when you try to quit weed. Day 1 to 2 of quitting is when withdrawal symptoms start. A meta-analysis of over 23,000 people found that 47% had at least 3 of the following withdrawal symptoms: nausea, headaches, depressed mood, difficulty getting to sleep, sweating, anger, nervousness, decreased appetite, and strange dreams. Ding! Now, the risk of withdrawal symptoms is proportional to the amount of marijuana you've been consuming. For example, someone who consumed marijuana 3 times a week would likely have less withdrawal symptoms than someone who consumed marijuana every day. Day 3 of quitting is when irritability and anxiety peak. Thankfully, they begin to dissipate in the coming days, but on the other hand, the strange dreams and difficulty getting to sleep only begin to increase on day 3. This information has led to new research suggesting that chronic cannabis users may induce intrinsic sleep problems. Around day 4 of quitting is when the amazing physiological changes in your brain start to occur. Marijuana contains molecules which mimic natural neurotransmitters that are already in your brain called cannabinoids. At baseline, cannabinoids circulate at lower quantities in your body, but when you ingest marijuana, you create an influx of cannabinoids into your system, most specifically an increase in the psychoactive component THC, aka delta-9 tetrahydrocannabinol. Which is what I like to call it. THC is for noobs. When I see someone with an edible, I say, how much delta-9 tetrahydrocannabinol got in there, bud? The THC you've consumed while getting stoned resembles the natural neurotransmitter anandamide and creates increased neuronal activity in certain parts of your brain, which cause thoughts, imagination, and perception to magnify. The THC binding to your neurons also affects dopamine and norepinephrine levels in the body, which can lead to euphoria, pain modulation, and anxiety. But the thing is, as you continue to consume weed, it becomes harder to quit. You start to create a desensitization and down-regulation of your endocannabinoid receptors, specifically the CB1 receptor. Since this receptor modulates systems of short-term memory, increased cannabis use means a decrease in short-term memory. THC also affects neurons involved in the experience of novelty. When THC binds specific neurons, the influx creates an exciting sense of novelty even for mundane, repetitive tasks like washing dishes. It's why you might get stoned and walk down your same street and feel like everything is heightened. It's like, wow, is everything in bloom. It's the middle of winter. But regular cannabis use leads to the downregulation of these same neurons, making it harder to quit and making it harder to feel the bliss of a new experience while sober. After too much weed, you might go to Paris for the first time and see the Eiffel Tower and be like, that's it? Is it a lighthouse? Oh, it's pointless. Okay, cool. Should we go up it? No, let's not go up it. we should just go home. But thankfully, on day 4 of quitting marijuana, the CB1 cannabinoid receptors will likely have returned to normal functioning. Essentially, it only takes around 4 days of quitting marijuana for the neuronal changes in your brain to go back to baseline. Now, this is new research, and I think it is important that we continue to study this, especially as the popularity of weed skyrockets. We need lots of long-term evidence about how this could be affecting our brains. I am focusing on how the THC affects the systems in your body. How you get that THC into you might involve smoking, and the act of smoking could have lasting effects on your lungs. But there is actually a specific way that the THC in your system can have longer impacts on your neurology in your brain. If you consume too much marijuana during development, such as in adolescence, you can create long-term neurophysiological effects. So yeah, I started smoking weed in grade 10, which by definition is adolescence, so whoopsies. As a closeted gay kid in a high school with no other gay kids, I was sort of drawn to that stoner skater crowd because, to be honest, they were the most fashionable. I also always had this gay voice, so when people would come up to me and be like, "You're gay," I'd be like,
"Actually, no, I'm sort of like a quirky, cool, like skater, bro."
I'm Avril Lavigne, but a boy. Get it? As a queer kid, weirdly, weed was an asset for me. But all those reasons aside, scientific evidence now suggests that I could have been doing long-term damage to my neurophysiology. So was it worth it? Because when it comes to marijuana's lasting neuronal effects, the age of your brain matters. Okay, but back to day 5 to 7 of quitting weed. A recent study found most people who tried to quit marijuana would fail on days 5 to 7. And it was hardest for people who were dependent on marijuana. Marijuana dependence can be defined as someone who has consumed weed daily for 10 years and has attempted to quit numerous times but not made it past day 7. It can also be defined by a continued use of marijuana despite social, psychological, and physical impairments. It should be noted that although many scientists agree that marijuana dependence does exist, they also agree that dependence on marijuana is less severe than dependence on alcohol, cocaine, or opiates. But for marijuana, days 5 to 7 are important days to focus on when trying to quit, as statistically, they are the biggest hurdle. I mean, I feel this. I still consume weed. Yes, it's been decades. Thankfully not daily, but I do wonder if I'm dependent. And it is on day 5 to 7 where I usually find myself ordering a little edible from the Gov and taking my Just Dance skills to the next level. It's also honestly because the weekend comes and I want to watch a movie stoned. To be honest, in my adult years, I don't know if I've ever entered a movie theater not stoned. For me, movie theaters represent the munchies, and spending about $79,000 on their largest popcorn, also getting chocolate to pour into the popcorn, then the gummies to eat to take the popcorn out of my teeth while I'm eating the popcorn, and also nachos with an extra fake cheese so I have enough fake cheese to kill a small horse. But finally, if you make it to day 28 of no weed, all withdrawal symptoms disappear, your affected endocannabinoid system and CB1 receptors will return to baseline, and you might be able to understand a movie. So I'm not saying that you just have to go out there and quit weed right now. For example, that's not what I'm planning to do. But I think it's really important to understand what will happen to you if you do decide to quit. Life is hard, and I do think that education and learning is what allows you to make the best choices for you. And I think science shows us that quitting weed isn't as easy as we might think it is. You can click a link to our podcast where we discuss more about the science of quitting weed. Make sure you're subscribed, and we'll see you next week for a new science video. Peace.
Welcome, everyone. I'm Emily Sine, tonight's moderator. You just saw these quotes from these noted actors, musicians, authors, and scientists, and they all credit psychedelics with providing them
Right now, 55 million.
There is one 5-word question you should never ask a woman if you want her to sleep with you, become your girlfriend, or see you as anything more.
Penis sizes are shrinking, which you might have seen from these headlines all over the internet. And in the last 40 years, sperm counts in men have decreased by 50%, and the distance between the anus and the genitals in boys, aka the taint, has been shrinking. So today we are going to explain what is going on. Testosterone levels in men have been declining since 1982. A meta-analysis of over 185 studies that looked at over 48,000 men found that between the years of 1973 and 2011, male sperm concentration had decreased by 52%, and overall sperm count had decreased by 59%. 26% of men who have erectile dysfunction are now under the age of 40. Looking at sperm bank semen in 1963, 1 teaspoon of sperm, which is your average ejaculation, would have had 99 million viable sperm per milliliter. By 2011, it had fallen all the way to only 49 million viable sperm. And the decrease in the sperm count, sperm concentration, and viable sperm is why now male fertility issues contribute 1/4 to 1/3 of all fertility issues. And now we are starting to understand finally why this is happening. It comes down to plastics, pesticides, and the chemicals in the products that we are using every day. Plastics, pesticides, and chemicals in our products contain EDCs, endocrine disrupting chemicals. These chemicals can bind to hormone sites in our body and fool our bodies into thinking they're the natural hormone. Hormones are signaling molecules in your body that are a part of your amazing endocrine system. The endocrine system consists of these glands in your body that secrete hormones in order for your organs and your tissues to essentially communicate. For example, when stressed, your brain will signal your pituitary gland to release ACTH, and this pituitary gland is in your brain. No, it is not your testicles, even though it looks like it. The ACTH enters the blood where it then makes its way to your testicles, even though it looks like it. The ACTH enters the blood where it then makes its way to your adrenal gland. Now the adrenal gland secretes cortisol, another hormone that enters the bloodstream and then increases glucose within your body to help you deal with that stress. This is just one example of endocrine biological signaling processes, but there are many more that control how you breathe, how your digestion works, and even the sensory you feel when you touch a wall. Back to the endocrine disrupting chemicals, or EDCs. They can also control how our natural hormones are broken down and stored. And they also change our body's sensitivity to the real hormones. So let's start with the endocrine disrupting chemicals, phthalates. These chemicals are in plastics because they make them soft and flexible. They're also in floor coverings and soap and hairspray. One study of 72 common household objects found phthalates in 3/4 of the products, such as deodorant and hair gels and fragrances. So in rats, if the expectant mother is exposed to phthalates 18 to 21 days after mating, the male pups will have a decrease in testosterone. In humans, if an expectant mother is exposed to phthalates between week 8 to 12 of the embryo's development, it can disrupt testosterone and lead to boys coming out with a decreased penis size, lower sperm counts, and a smaller ADG, a smaller taint. Now let's look at the BPA, which you may have heard a lot about. It can be found in non-stick coatings, in lots of different plastics, in electronics, and also in receipt paper. Men working at factories with high levels of BPA had their urine examined. It turned out that increased levels of BPA in their urine led to 4 times lower sperm counts, 3 times lower sperm vitality, and decreased sperm mobility. Sons of men with high BPA exposure had decreased ADGs and were more likely to have ejaculation issues and decreased sexual desire. And there are a lot of other chemicals that disrupt endocrine hormones, from those in plastic toys and air fresheners, nail polish, pesticides, to the grease and stain repellents in fast food containers, and the dioxins found in meat and dairy, all of which have an impact on sperm count, taint size, or penis length. It's not just EDCs and plastics and pesticides that are decreasing male fertility, it's also other things that we are just doing to our body. Smoking cigarettes, or even just exposure to secondhand smoke, can actually cause damage to our sperm. It can decrease our testosterone and decrease our ability for the little guys to make its way to the egg. And right now, men smoke 5 times as much as women, which is causing a decrease in male fertility. And it's not just cigarettes, sadly. Also, those marijuana smokers, like me, also have to look out, because a 2015 study in Denmark found that smoking marijuana more than once a week led to a 29% decrease in sperm count. Also, curing meat with nitrites and nitrates and the chlorinated pollutants that can be found in animal meat and dairy can damage your sperm's DNA. Men who eat more processed meat have a decreased sperm count and decreased normally shaped semen, and this could be caused by the endocrine issues that these chemicals in these meats have. One thing is becoming extremely clear, which is that the chemicals we are now using in our modern world are creating a decrease in male fertility. So much so that a variety of studies have found a 1% decrease in testosterone in men per year since 1982. As for what you can do right now at home, you can eat less meat and dairy. You cannot heat up things in plastic containers because that can actually have the chemicals seep into your food. You can eat less takeout and fast food, as the actual packaging can be an issue in those cases, as well as the gloves that fast food workers while they're preparing your food. One study found that teenagers who ate out more had a 55% increase in some of these EDCs compared to teenagers who solely ate at home. If you do use a non-stick pan, keeping the heat low and for shorter periods of time. And if you ever see any sort of flaking on them, get rid of them. Phthalates can leach into food in processing practices and in food packaging. So eating less processed food or food with less packaging can also help. We need to regulate corporations so that they can't just use these chemicals on us. Right now, corporations can experiment with our bodies. The way that this regulation works is kind of innocent until proven guilty. So only when we start to realize the detrimental effects of these chemicals do we then start to regulate them. We need to change that order. You may have seen this tweet from Greta Thunberg. I think it's rather smart and funny, and we will see you at the next climate march. We need to hit the streets and hold our governments and our corporations accountable when it comes to regulating these chemicals out of our bodies. They need to keep us safe. They need to help us lead healthier lives. And we didn't even really know the effects that these chemicals were gonna have on us. And now that we do, we need to figure out how to get them out. This is really important so that we can keep all of our and if you want to learn more, grab the book Countdown by Shanna Swan. She's sort of ringing the alarm on all of these issues. I am just helping her try and get this information out there. The book is full of amazing resources and gives you a really great understanding of what is going on here. Thank you so much for watching, and we will see you next week for a new science video.
This is a video about things, like cars, phones, and light bulbs, and an actual conspiracy that made them worse. This video was sponsored by NordVPN. More about them at the end of the video. I am outside Livermore Fire Station number 6, and in here, they have the longest continuously on light bulb in the world.
Thanks to Skillshare for sponsoring this episode. This was humanity's first introduction to nuclear power, the atomic bomb.
And this is a nuclear power plant, which you may know from all the times that they've broken down in history and scared the crap out of people. Hello, HBO's Chernobyl.
But you've actually been lied to about nuclear energy. And in order to understand those lies, we first have to talk about where the energy comes from.
In 1938, scientists discovered nuclear fission. They did this by slamming an atom of uranium with a neutron. It would divide into two and release a large amount of energy. Not only this, but during the nuclear fission reaction, up to 3 neutrons are ejected, which can trigger further fission reactions of more atoms, meaning more energy is released. This is known as a chain reaction.
During World War II, America would use this same technology to create the first atomic bomb, but it wasn't until 1955 that the same scientific principles were used to create the first nuclear power plant that generated electricity.
In the 1970s, psychologists started to map people's anxieties about nuclear destruction and the past Cold War onto nuclear power plants, which were now cropping up around the world. Then came the 1979 thriller The China Syndrome, a movie about a fictional nuclear reactor meltdown, which was released on March 6th, 1979, and just 22 days later, a real partial nuclear reactor meltdown happened at 3 Mile Island. Talk about free advertisement for your movie. The coincidence of a Hollywood film and this cultural nuclear reactor breakdown coming together really shot into the mainstream this negative connotation with nuclear energy. From the release of this movie to 1988, 67 planned nuclear power plants were canceled. In 1986, Chernobyl happened, which was caused by human error as the temperature of the reactor core became too high and an explosion created a nuclear cloud across Europe. I scream cried while watching Chernobyl. I remember thinking to myself, okay, is nuclear energy a truly invisible horror? Right after that, in 1989, we get The Simpsons, where we see people diving into nuclear waste, and our favorite idiot Homer, who we all picture as a safety inspector at a nuclear reactor. As recent as 2011, we have the Fukushima nuclear disaster, and all of this combined made it really hard to not be afraid of nuclear energy.
But when you look more into it, you find that no one died at 3 Mile Island, and most epidemiological studies found that it had no detectable health consequences. After 30 years, only 51 people died from the incident at Chernobyl, and scientific studies found few health risks connected to radiation exposure after Fukushima.
Take this recent In a Nutshell video linked in the description. It shows how using coal, oil, natural gas, and biomass has killed 100 million people in the past 50 years. This was due to pollution created by the byproducts of burning fossil fuels.
The World Health Organization explains that it's safer to work in a nuclear power plant than in a big city office, as the urban air pollution of ozone, sulfur dioxide, carbon monoxide, and nitrogen dioxide causes 7 million deaths annually.
Only 0.005% of the average American's yearly radiation dose comes from nuclear power. This is 200 times less than a cross-country flight, 100 times less than what we get from coal, and about the same as eating 1 banana per year? Wait, so if I'm scared of nuclear energy, I also have to be scared of a banana? But like, peanut butter and bananas on toast is my culture. Also, being gay, I hate holding bananas like this because it just reminds me of getting bullied.
There's also this study showing that a CT scan of the abdomen involves about 10 times the radiation exposure that the average nuclear worker gets in a year.
Or that living in a big polluted city increases your mortality risk by 2.8 times that of a Chernobyl cleanup worker. So what is happening? Is nuclear energy dangerous or safe?
But just before we get to that, we want to thank today's sponsor, Skillshare. The first 1,000 people to use the link in our description get a free trial of Skillshare Premium membership, so go check it out because it goes fast. Skillshare is actually how I improved my own animation skills to animate this channel with Greg's drawings. I also taught myself Photoshop using Skillshare, and it's just an amazing way to continue to learn and grow your brain.
Skillshare is an online learning community with thousands of classes for curious and creative people. You can explore new skills or deepen current passions, like this course that I took for beginner birders, where it actually taught me to correctly identify mourning doves. It was so exciting. It turns out that their wings make a specific type of noise. I'm obsessed with birding. Or this class about electricity generation, where you can take a deep dive into solar, wind, and nuclear energy and actually understand the physics and mechanics of generating this electricity. This was integral for me making this video.
It's curated specifically for learning, meaning that there are no ads and they're always launching new premium classes at the cost of $10 a month with an annual subscription, which is amazing.
So you can help our show by clicking the link in the description, and the first 1,000 people will get a free trial of premium membership. This genuinely is how you guys can support us here at ASAP Science. Now let's get back to the core of this video about the nuclear reactor's core. These reactors use low enriched uranium and controlled chain reactions to heat pressurized water, which in turn heats other water in a secondary circuit that causes steam to rotate a turbine, which is linked to a generator that creates electricity. Cool water from a river or ocean can be pumped in to cool the water in the secondary circuit, or sometimes cooling towers are built, like these iconic bad boys that we all know and love from The Simpsons.
Current research has found that American opinions haven't changed much on nuclear energy since the Cold War, which is weird because it feels like culture has shifted. Kids no longer learn to hide under their desks in preparation for nuclear war. Now they learn to hide under their desks for preparation of a mass shooter. In fact, 54% of Americans still oppose nuclear energy today. So let's talk nuclear power plant safety. A Harvard study found that newer generations of nuclear reactors, particularly what is called pebble bed reactors, are designed so that the nuclear chain reaction cannot run away and cause a meltdown, even in the event of a complete failure of the reactor's machinery. And that with the advent of modern reactors such as the pebble bed reactor and careful selection of plant sites, nuclear accidents like the one in Fukushima are actually not possible. But some people think that emphasizing safety actually just emphasizes fear. Airlines don't advertise how safe they are because then you would just be thinking about crashing the whole time you were on the plane, and the fact that you need to look next to the stranger beside you and be like, I love you, I'm sorry, goodbye, while you're screaming and the plane's shaking and you have to cover your head and apparently your legs break on impact.
So maybe nuclear energy should use the airlines approach and stop explaining why they're safe and start unapologetically explaining how great they are. Nuclear reactors such as Diablo Canyon, which will be closed in 2024 due to cost upkeep, accounts for roughly 9% of California's energy, but occupies fewer than 600 acres. Honestly, that's wowzers to think of that much energy coming out of that little Diablo Canyon. There are currently 56 nuclear power plants operating in the US that provide the country with roughly 20% of the electrical supply. That's more than half of the US's low carbon electricity. The NASA Goddard Institute predicts that nuclear power has prevented 1.84 million deaths that would have occurred if the energy was produced by fossil fuels. This is 370 times more lives saved than have been lost to any nuclear power plant issues in the last 40 years. At this point, I feel very lied to, but what about the nuclear waste?
97% of the waste created by nuclear plants is classified as low or intermediate level waste. All the nuclear waste in the US is often compared to the size of a football field piled 50 feet high. The World Nuclear Association describes that the waste is encapsulated in highly engineered casks in stable, vitrified form and is emplaced at depths well below the biosphere. Such long-term geological storage solutions are designed to prevent any movement of radioactivity for thousands of years. So even in the event of an earthquake or natural disaster, these repositories will keep the waste from reaching the surface and releasing radiation. In addition, 96% of this waste can be recycled to make new fuel and byproducts.
So the nuclear power industry puts their waste in monitored concrete casks deep into the ground, but the coal, oil, and natural gas industries release their waste into the atmosphere, where it causes pollution and kills thousands of people a year and like all the birds. And these greenhouse gases contribute to the 6th largest mass extinction that we are currently in and to the climate crisis that we are currently in. So is it safe? Well, nuclear energy is definitely safer than the fossil fuels that we are addicted to right now.
The fear of nuclear energy is getting in the way of us having an honest discussion of how it can work with renewable energy to get us to a zero carbon future. As stated, the US gets 20% of its electricity from nuclear power plants. France gets 70% from nuclear. Impressive research at MIT analyzed 1,000 scenarios of getting to our zero carbon future, and all the cheapest paths involved nuclear helping renewable energy get to where it needs to be.
Focusing in on America, there is a scenario where you can get to a zero carbon future with just renewables and leaving the existing nuclear power plants on. But this is specific to America because America is rich in renewable energy opportunities. It's got the windy Texas, the super sunny California. Many other parts of the world do not have the ability to rely on renewable energy in this way. It's for this reason that the UK has put nuclear front and center for how it's going to get to zero carbon emissions, because they can't really rely on solar and wind in the same way. China is also currently building nuclear reactors due to their increasing consumption of energy.
Now, up to this point, we've ignored a really important part of this conversation, the economics. Explained really well in this real engineering video, linked in the description, nuclear power plants are extremely expensive to create. Since 1996, only one nuclear power plant has been made in the US, and likely due to the cost, not fear. Take the crappy scenario in South Carolina where a $9 billion nuclear plant wasn't finished, and now the people of South Carolina are paying for it even though it's releasing no energy.
But innovation in the nuclear power space could make reactors that are smaller and much more cost effective. We all know that we need to scale up renewable energy, and there have been amazing strides made across the earth, but we can't allow our irrational fear of nuclear energy to stop its ability to innovate. A great start would be to look at the climate platform drafted by John Kerry and AOC, which included a plan to create cost-effective pathways for developing innovative reactors. The biggest lie about nuclear energy is the way it's been depicted towards us in culture, whether it's from The Simpsons, which honestly made me honestly scared about nuclear energy. That lie is real. I feel like I was so scared about nuclear energy until I started to do all this research about the climate crisis and realized that we probably need it.
I think the biggest takeaway from this is that we need to stop the infighting. We're all against the fossil fuel industry and we want to save this planet and we want to get to net zero carbon emission as a society, and it's a great option for us to come together.
Whenever we talk about nuclear energy on our channel, the comments are heated. It's like a Cold War, okay? People who are pro-nuclear are like, if we don't use nuclear, we're gonna become tree huggers hugging lefties and like marry a solar panel. And people who are anti-nuclear energy are like, if we use it, we're all gonna die. And I'm just like, okay, we need to stop this infighting because we need to be talking about the dangerous fossil fuels that we know and are currently killing all of us. So where do we go from here? We want your help with this. This is not a simple answer, so please, in the comments, let us know what you think. Have you been scared of nuclear energy? Is nuclear energy something that you believe in, something that you're against? We will be there and we will be responding to you.
And maybe we'll be talking about the new nuclear fusion reactor as well, which is so cool. So check out the links in the description and we'll see you there.
Thank you so much for watching, and we will see you next week for a new science video, or maybe a climate change video. Peace.
Hi, I'm Alex Lopez from the Aperture program. My first experience with Internet Explorer 3 was over a dial-up connection in my suddenly popular school library. I didn't know it then, but that first step into the World Wide Web would eventually remain an open window that connected me to some of the most meaningful experiences of my life. Over the years, Internet Explorer allowed me to stay connected with friends and family around the world, search healthy recipes I'll never make, and collaborate on documents.
Welcome everyone. So this is a very special and rather unusual event. Spacetime has always been about digging towards the deepest layers of reality. For nearly 100 years, it's felt like we've been hovering just above the bottom layer. And so my friend and colleague Brian Keating and I decided that the fun thing to do would be to bring together today's frontline researchers in physics, experimental and theoretical, for a real conversation. So, now, Brian is a distinguished professor at University of California, San Diego, director of the Simons Observatory, and host of the Into Impossible podcast, where you will find the craziest line of the most incredible guests. So please check that out. He's also the author of the book, Losing the Nobel Prize. So if you want to know more about Brian and his amazing work trying to understand the origins of the universe, that's where to look. So, Brian, thanks for joining us.
Yeah, thanks, Matt, and thanks to the whole PBS Spacetime Studios family out there in cyberspace. This has been a dream for me to talk not only with Matt and his team, but also with my good buddies. Today we have Stefan Alexander, who I've known for, I'm embarrassed to say, what fraction of the universe we've known each other for. Max Tegmark, I've known him almost as long. And James Beecham, I'm a huge fan of, fellow experimentalist looking to solve some of the world's greatest problems in the world of physics. And today is quite fitting. It's two occasions are marked today. Well, one specifically, today is Karl Popper's, would have been Karl Popper's 118th birthday. And some say he doesn't look a day over 70. But Karl, of course, casts a large shadow over all of what we try to do as scientists. And the question is it still relevant, this conjecture, to pursue these fanciful ideas about theories of everything and whether they exist? So part of the motivation is to address that very question. And the other part is to rekindle the series of great debates that took place in the 1920s, actually in April 1920, the first so-called great debate, the Curtis-Shapley debate, which concerned what is the nature of the universe on its largest scales. And so today we now know that the universe's largest scale properties are determined in part by how it functions at the micro level, namely the laws of physics. And so these physicists who are so distinguished joining us today are going to hopefully shed some light into the nature and the inner workings of the universe and be a really good starting point, perhaps, to kick off many more great discussions this year, in the centennial year of the great debates.
Awesome. Thank you, Brian. So I'm going to bring on our guests because they have the real content here. Quick introductions. So we have James Beecham, who's a particle physicist with the ATLAS experiment at the Large Hadron Collider at CERN, and he's also at Duke University. And James is really the experimentalist in the room, and so he's going to be the one who keeps us in check. We have Stefan Alexander, a cosmologist and theoretical physicist with really a hugely broad range of interests, including string theory and loop quantum gravity. In principle, we could do this entire conversation just with Stefan. He's worked in everything. He's also a brilliant saxophonist and author of the book, The Jazz of Physics. And of course, we have Max Tegmark, a theoretical physicist with an extremely broad background also. So he's worked in fields from cosmology to the foundations of quantum mechanics, and now actually working deep in the field of deep learning. And he's the author of multiple books, including Our Mathematical Universe and the recent book, Life 3.0. So, hi everyone. Thanks for joining us.
Hello.
It's a pleasure to be here.
Yeah, thanks for having me.
It's good to see you all in your far-flung isolations across the globe. So we have a lot that we need to talk about today. You know, we're not going to necessarily solve the theory of everything or even fully solve what the problem is in our search for a theory of everything. But I feel like we might be able to make a little scratch today. Before we actually get deep into that, I thought it might be a great idea for us to set the stage and really talk about what we mean by a theory of everything and the related terms. And I felt that the most unbiased person to do that is probably you, James, as an experimentalist.
I'm happy to do so. And in fact, let me say that I think, you know, I want Brian and Matt putting this fantastic discussion together because it couldn't be more timely. And the reason, you know, if you ask the question, what is a theory of everything? Why are we here to even talk about this? It's a really good question because down deep inside, the answer to that question is related to the fact that physicists, for all of us, you know, we seem sometimes kind of stuffy and nerdy and very kind of analytical. Deep down inside, we're very, 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 very frustrated for the following reason.
Fancy plane rides, pink Lamborghinis, and giant homes in California. Influencers love to flaunt a lavish lifestyle, but what would actually happen to the planet if everybody lived like an influencer?
Better yet, how many Earths would we need to sustain the lifestyle of everyone saying?
Make sure you give this video a thumbs up, make sure you like, subscribe, and you cop that merch below, bros.
Let's start with
driving, the thing I hate most on Earth. The most famous influencers live in America, where 6 million cars are purchased each year, and in the year 2015, Americans' combined driving length was from Earth to Pluto and back 500 times. Most specifically though, influencers live here, in the epicenter of the entertainment industry, La La Land. You might be a romantic and think of LA as the city of leading men swinging their arms and dancing on the big screen. But now it's more like beefcake men swinging something else on the small screen. In LA, on average, people drive 9.3 miles per day, which feels insane when you're from a place like Toronto, but it's actually 54% less than the rest of Southern California. This is because many Angelinos, which is what you're called when you live in LA, which is kind of amazing, take public transit. But when is the last time you saw a vlogger or a YouTuber on a bus? They'd be like, oh my god, is this on? Do I look okay? It's taking a lot for me to tell you this, and you know how much I love you guys. Something really crazy happened to me, like story time, okay? I had to take a bus.
And the cream of the crop celebrities or influencers live here in the West LA Hills, aka the Hollywood Hills. According to public data, people who live here drive the most out of everyone in all of LA. And things add up quickly as any employee or friend also needs to drive up into these hills to get to your house, leading to an average of 11.1 vehicle miles traveled per day. This is why we constantly see influencers making videos in their car like this.
Hi, sisters.
Hi. Oh gosh, that was kind of scary.
Also, did you know that 20% of meals in America are actually eaten in the car? The American dream.
So guilty.
But if we're all rich influencers, we can afford to buy an electric vehicle like a Tesla, right? Let's assume we can. Buying a Tesla is still actually worse for the environment than taking public transit, and charging it still relies on the current power grid. Also, I am aware of the irony of me filming this in our car. I mean, we're influencers after all. And since we're in Cali, it's not that bad. California has amazing renewable energy sources. In 2018, only 3.3% of the power grid came from coal and 0.16% came from crude oil, compared to the rest of America where 13.1% comes from coal and 36.4% from crude oil. So charging a Tesla in LA is pretty green compared to the rest of America and even the world. But California still relies pretty heavily on natural gas, not to mention the raw materials it takes to make a Tesla in the first place. When you add it all up, it starts taking a toll on the earth. Based on eco-footprint calculations, we would need 4.3 Earths to sustain a world where everyone had the same driving lifestyle as an influencer. That's just based off of driving in some pretty ideal conditions. But what about their
mansions? Huge houses require a lot of energy and electricity. To start, Americans consume 15% of the world's energy and 20% of the world's electricity, but make up only 4% of the world's population. For context, the people of India and sub-Saharan Africa consume only 10% of the world's electricity, but make up 33% of the world's population. Influencers tend to flaunt these large, gorgeous, costly homes, but the true cost is on the earth. Take just air conditioning, for example. More than half of the air conditioning units in the world are in China and the US, and keeping them running uses 2.5 times more electricity than the whole continent of Africa uses in a year. One study I found calculated that 6% of all electricity in the US is used for air conditioning, and air conditioning our homes causes more than 100 million tons of carbon dioxide emissions every year. Not to mention the cement or concrete that's needed to build these large homes, as surprisingly, concrete accounts for 5% of global carbon dioxide emissions and is the second most consumed substance on Earth after water. But a lot of these influencers do their best. They carpool. They don't always eat meat. They are minimalists. Is that what this is? This looks like an evil villain's lair in a Disney movie. Even if we assume that these influencers never eat meat and that they have some energy efficient appliances in their home, you can run a calculation to find out that if we all drove and had mansions like LA influencers, we would need 10.9 Earths to sustain the lifestyle.
So hold up, how are we calculating the amount of Earths? Using geographical locations and behavioral averages for income and neighborhood information, we can measure an influencer's global hectares. This measurement looks at how much land, sea, and other resources are needed to produce what each person's global hectare will be per year. And there's many online calculators where you can figure out your own eco footprint. But we're actually gonna need a lot more Earths because influencers and us right now are using a service that emits a lot more carbon dioxide than you might think, and that is
online video platforms. The energy needed to store, deliver, distribute, and even watch online video leads to 0.4 kilograms of CO2 emissions per hour. In 2018, 228.8 million people in the US watched digital content for 82 minutes each day, adding 1.3 billion kilograms of CO2 to the atmosphere per year. So if we all became online influencers, our CO2 release would be astronomical. Plus, we'd be uploading so much and then downloading so much, so the servers and the energy to cool the servers would be insane. Did you know that they're trying to put servers up in the Arctic so we don't have to spend as much money trying to cool them and as much energy trying to cool them? Either way, uploading and downloading all this video would be really bad for the planet. Not to mention
the closet. Back in the closet, I see.
Hello, darkness, my old friend.
The fashion industry is the second most polluting industry in the world, responsible for 10% of greenhouse gas emissions. MIT calculated that the global impact of producing polyester alone was somewhere around 706 million metric tons of carbon dioxide, or about what 185 coal-fired power plants emit in a year, let alone selling the products. So if 80% of people in the majority world shopped like influencers in LA, we would see a 77% increase in carbon dioxide emissions associated with clothing production, a 20% increase in water usage, and 7% increase in land use. Who knew you'd have a gay man telling you to shop less? Usually we just have girls being like, oh my god, be my gay best friend, come shopping with me. It's like, honey, if it ain't a circular economy, it ain't happening. Not really killing it as the gay best friend right now, am I? We'll include all that info in the final tally of global hectares, but before we get to that, let's talk about an influencer's favorite substance. And I don't mean tummy tea. I mean
oil. Half the world's oil is consumed by only 17% of the world's population. These countries are known as the OECD nations, and they are also responsible for 33% of the world's CO2 emissions. America itself produces 15% of the world's CO2 emissions, compared to Bangladesh, who has half the population but only produces 1% of the world's CO2 emissions per year. Remember the sprawling mansions we mentioned earlier? People in Bangladesh do not live in these. The 163 million people of Bangladesh live within their country, which is the size of about Alabama. Americans, on average, consume 10 liters of oil a day, but we Canadians fare even worse at 10.2 liters of oil a day compared to a Bangladeshi who only uses 0.1 liters of oil per day. A lot of this oil is used up from flying, which is something that influencers love to do even during a global pandemic. Ding! Even if we keep the influencer lifestyle vegan, we're also going to assume that they're pretty much shopping only local. They got those expensive LA grocery stores. We're going to include a flight from New York to LA every 2 months, which I think is actually being kind of generous for influencer lifestyles when you study them, but we're going to put that in as well. We discovered that if everyone lived like an influencer, we would need 12.9 Earths to sustain the lifestyle. So what can we collectively take away from this?
We made this video to dissect the idea of the aspirational lifestyle that affects all of us, including us. I mean, I've got a fig tree back there, I want it to look pretty. We're all impacted by the consumption habits we see online and in media. But if we all lived like Bangladeshis, we would only need this much of the earth to sustain all life, which is astounding. And in our current climate crisis, are these not in some ways an aspirational lifestyle? I know this can get complex and muddy when we talk about poverty or the quality of life, but the Global Happiness Council found that in 2017, Americans were the unhappiest they'd ever been since starting that initiative, even though they were working, eating, driving, and consuming more than ever. In fact, if we came together as a species and evenly distributed our fuel and energy consumption across the 7 billion people on this planet, we would all have the same energy use as somebody in Switzerland in the 1960s. Look at those gorge trams. Look at those cute little outfits. They honestly look happy. And the life expectancy of somebody in Switzerland in 1965 was the same as it is in America today, which is much higher than the world average. For more information on this, you can check out our podcast on YouTube, which is all about influencers, with the link in the description. Ultimately, we're not advocating to live in substandard conditions, but to just question, are we actually in better condition today now when we're consuming more than we might have been in the past? And can we reevaluate our beliefs and our ideals about this aspirational lifestyle and what it means to have lots of things?
And now let's talk about the elephant in the room. We are from Canada, if you cannot tell. We drive around in giant ass vehicles like that one. Please blur out the license plate or we could get sued. That's a gas guzzling machine if I've ever seen one. So just by living in our culture, we are treating the world unfairly. We are contributing to CO2 emissions more than most people on this earth. And although Mitch and I like to call ourselves queer science educators who try to use comedy and drawings to make sure that science is for everyone, sometimes my friends will go to a party and say, oh, this is my friend Greg, he's an influencer. At this point, I will usually push them over, smash a plate, and drop kick them in the face.
Something we can try and work on as influencers is to stop selling this culture of consumption and money and capitalism.
First class flight.
Yeah, like the luxury of it all, because we know that's not good for the environment or the planet, even though it does well on the YouTube algorithm.
It honestly does. Mansion tours all over the place.
I just think it would be cool if culturally, and I see this movement slowly happening, we could agree that it's actually not that interesting to just have lots of money, to just buy things that are way too expensive that in the first place often exploit places that don't have as much money.
Yes, the responsibility is always on corporations like YouTube and Google and the government, but we as people also have to have a hand in thinking critically about these wealthy, luxurious lifestyles and what we actually think is quote unquote cool. The climate crisis is going to be probably the most defining thing that happens in our lifetime, and we know that like dominating our natural environments to create these wealthy lifestyles is not going to help. So yes, we are influencers who made this video.
Classic. I know it's a lot harder than it sounds. You can't just change culture overnight, but I do think it would be interesting to challenge the ideas that luxury and opulence and all these things are something that we should all desire and want, because they're literally impossible. We would need 12.9 Earths to sustain them.
Thank you for watching this. Comment below your opinions. We're so curious. We're thinking about this stuff all the time. Subscribe for more science and climate change related videos, and we will see you next week.
See ya.
Hi, I'm Alex Lopez from the Aperture program. My first experience with Internet Explorer 3 was over a dial-up connection in my suddenly popular school library. I didn't know it then, but that first step into the World Wide Web would have
If you had to choose between your eyeballs or your eyebrows, which would you keep? My guess is most people are saying they would keep their eyeballs, obviously. Eyebrows are just this weird forehead mustache that we all have. But what if I told you that eyebrows are way more important than you might think? Take a look at these photos of celebrities with their eyes removed and try to name who they are as quickly as possible. Here are the answers for those still wondering or unsure. Now, do the same thing with these photos of celebrities missing their eyebrows. Besides all these pictures being absolutely weird and hilarious and uncanny, studies have shown that people have a significantly harder time on average recognizing faces without eyebrows compared to those that are missing eyeballs. Okay. I immediately feel insane. I will keep this on for a very brief moment because I know how unsettling it is, not only for you, but for me. And I'm not gonna not be able to stare at myself in the camera. So here we go. Now, you may not have known who all those celebrities were, or perhaps you recognize the ones more when they didn't have their eyebrows, but it's important to remember that the studies found, on average, after studying many people, that when eyebrows were removed, it was harder to recognize the faces. Why would removing the eyebrows have such an impact on recognition, especially over the eyes and mouth, which we've always sort of assumed are the main emotive and recognizable features of a face? So much so that most of our facial recognition software that we interact with relies on our mouth and eyes, which you might have noticed in a world where we now wear masks and your phone's not able to even recognize your face until you take it off. Okay, this has to go now. If you need even more evidence that eyebrows are weird yet important, take a look at the Mona Lisa. Perhaps the most famous and enigmatic painting ever has no eyebrows. Coincidence? Like, what if she's just actually a famous celebrity and none of us can recognize who she truly is? In all seriousness though, the science is really cool, and next to apes or monkeys, it becomes glaringly strange and something I'd never really noticed before. They have nearly full faces of hair, and yet we only really retain visible hair on our eyebrows. Not to mention our massive hairless foreheads in comparison. Even next to a human with a full face of hair, the skin ratio is so much higher. What's that about? Why did evolution lead us to lose most of our facial hair except this random little part above the eyes? I'm glad you asked. Well, one of the most distinct features of modern humans is actually our brow ridge, which you can clearly see when looking at our skulls. We evolved smooth, long foreheads and agile eyebrows compared to a stiff brow ridge of archaic hominids. A long-standing explanation of eyebrows was simply that they helped keep sweat, rain, and sunlight out of our eyes. After all, the hairs grow outwards towards the side of the face, which can help direct moisture or dirt away. Others have suggested that the different testosterone levels in early hominids or our brain's frontal lobe growing larger over time may play a role. But after further analysis, some of the most interesting and newer research has suggested that it may actually have to do with a very human trait: empathy. As we became an increasingly social species and relied more and more on communication, our eyebrows actually helped us to facilitate and show emotions, which increased survival. While early hominids likely preferred a heavy brow ridge as a show of dominance and strength, the need for this would have slowly diminished as communication became more useful. Think about the way that your eyebrows can communicate, sometimes even involuntarily, without even changing other parts of your face. Not only can you convey emotions that are big, like surprise, happiness, anger, but even minor movements of your eyebrows can cue subtle changes in your emotions, like being concerned or concentrating. A simple example is this cartoon face. Take the exact same face and only change the eyebrows, and you get 3 different expressions or emotions. Another advantage of your eyebrows for expression over, say, your eyes or your mouth is that they're an area of high contrast even from a distance. Whether you're looking at somebody from far away or even at a low resolution, eyebrows are often still visible and continue to make an important contribution to the geometric and photometric structure of an observed image. And since or even at an area of high resolution, eyebrows are from a distance. Whether you're looking at somebody from far away or even at a low resolution, eyebrows are often still visible and continue to make an important contribution to the geometric and photometric structure of an observed image. And since they sit at the top of your face and protrude slightly, they're less susceptible to shadows and illumination changes. Perhaps one of the most interesting things I came across was the use of eyebrow expression not only in sign language communication, but even the use of eyebrows in those who are completely blind. For deaf people, without vocal intonation, tone, or stressing words or syllables, the eyebrows help modulate and complement hand and body signs. A perfect example is the raising of an eyebrow, which naturally serves as a question, much like raising the pitch of your voice. The raising of an eyebrow, which naturally serves as a question, much like raising the pitch of your voice at the end of a sentence does. And for blind people, it turns out that even those that are blind from birth still express and use their eyebrows for emotions in the exact same way that sighted people do. When spontaneously surprised or disappointed, the muscles in the face and eyebrows contract and relax in the ways you would expect. Interestingly, where blind people differ is recreating facial expressions on command. Because sighted people have practiced using mirrors as a feedback system, it's much easier for them to recreate facial expressions when asked to. But perhaps one of the cutest examples of eyebrow importance comes from our furry companions, dogs. Turns out that dogs with the most expressive eyebrows are the most likely to be adopted from shelters. In fact, wolves, who share a common ancestor with dogs, physically lack the muscles to control their eyebrows and eyes, whereas almost all dogs have a muscle that pulls the lateral corner of their eyelid toward the ears, called the levator anguli oculi mediali. Expressive dog eyebrows are actually the result of unconscious human preference. We so value the communication exhibited from eyebrows that dogs that are able to express that way have a selective advantage. Honestly, I never thought I would find eyebrows so fascinating, but researching it and looking into it and realizing how connected they are to not only our evolution, but our ability to communicate as a species, not only with each other, but with dogs, obviously so cool, ultimately just illuminates how important these forehead mustaches really are. At the end of the day, it's an amazing and really interesting example of how some of our traits and their evolution have more to do with our minds than our environment. A huge thank you to Skillshare for sponsoring today's video. If you like our channel, you obviously love learning, and Skillshare is an amazing online learning community with thousands of videos for curious and creative people. I had to edit a lot of eyebrows off of faces for this video, to which I am very grateful to the Skillshare Photoshop Essential training course that I took. But I've also used it for improving my animation in After Effects. I'm currently going through one called Collage Animation by Carmines Guzmambit that does an amazing job teaching how to translate Photoshop skills into active animations. But Skillshare also have classes on music, business, and a ton of other interest areas. There are no ads, and they're always launching new premium classes, so you can stay focused and follow wherever your creativity takes you. And it's less than $10 a month with an annual subscription. However, the first 1,000 of our subscribers to click the link in the description will get a free trial of premium membership. So go click the link, quick, go on, click it. No matter what 2021 brings, you can spend it creating something meaningful with Skillshare's online classes. Thanks again for watching. If you haven't already, subscribe to our channel, and we will see you next time for some more science. Peace.
Why do girls lie about what they want? There's a very good reason. See if you can work out what it is. Take these examples. Why would a girl say she wants a gentleman and then chase after the jerk who keeps ignoring her? Why would she say,
Comedy isn't subjective? That can't be true. You may not like this joke, definitely not like this joke, and it feels like joke preference changes from person to person. But what if I told you that scientists have found a joke that is rated as the funniest? But before I get to the funniest joke in the world, I'm going to explain to you what makes something funny, why comedians keep getting canceled, show you a video of the first time I ever attempted stand-up, and end with what surveys say is the funniest joke in the world. In order to understand how scientists study jokes, you must first understand what makes something funny. It is found that on average, people laugh 17.5 times per day. I don't know what a 0.5 laugh is, like a ha ha. And a good sense of humor tends to always be one of the highest rated traits for friends, for spouses, and even lovers. Why are we so attracted to funny? It is predicted that human language evolved between 80,000 to 160,000 years ago, pushed by the evolutionary advantage of storytelling. Evolutionary biologists think it is because as a pack, it would have been helpful to tell stories about that other pack, to, talk about the dude over there who's kind of like killing everyone, or to maybe be like,
wait, where the berries at? Where the berries at?
In fact, a lot of theorists think that at first our language evolved as gossip, a way to sort of parse out and talk smack about the people around you in order to keep yourself safe by understanding who was dangerous and who was on your side. Humor and laughing, on the other hand, evolved as a signal to yourself and to others that things were safe, that things were okay. As hunter-gatherers, when we were laughing and when we were telling jokes, it meant that it was time to play, to socialize, and explore. That's why we still enjoy jokes now and comedians now and humorous things, because it's actually a sign that we are, in fact, safe. Which is really fascinating, because in order to understand the best joke in the world, you have to understand what it means to feel safe and unsafe at the same time. Known as the benign violation theory, a joke requires three things. 1, an unsafe violation of a situation. 2, a flip of that situation so it feels safe. And 3, both perceptions must occur simultaneously. Okay, this can sound confusing, but there is a clear metaphor to understand and remember this theory. If a friend tickles you, they are in fact violating you. But it feels safe because you know them well, you can laugh, you can have a little giggle, you can say,
"Stop, get off."
But if a stranger on the bus tickles you, yes, they are violating you, but there's no flip of that situation that feels safe. You feel unsafe, you push them away, you get upset, you don't laugh, maybe you pop their eyeballs out with your thumbs. It's a completely different situation. A good joke has to feel safe and unsafe at the same time. In fact, scientists took people and put them in an fMRI machine and made them watch The Simpsons and Seinfeld, and found that joke detection occurred in the left inferior frontal and posterior temporal cortices of the left side of the brain. That was a lot of big words, but this is the part of the brain that tries to make sense of contrasts and look for resolutions in our lives. Comedians have a brilliant way of talking about things that feel taboo, maybe we don't want to say them out loud, the darkest thoughts that we might have, and flipping them to feel resolved and safe so that we can laugh. And it is also why there can be such stark contrasts between what you think is funny and what someone else does. A lot of straight white male comedians are coming under fire recently for saying jokes that they think are safe, but audiences are telling them now are offensive. This is really fascinating because a lot of these jokes are at the expense of women or queer people or people of color, and historically comedians have mostly been white and male. In the 1970s, only 2% of professional stand-up comedians were women. In the 1990s, 20% of professional stand-up comedians were women, and now it's only 35% of professional stand-up comedians that are women. But it does mean that new voices have emerged in the comedy sphere, and comedy has essentially evolved because audiences are going to feel more safe seeing a woman make fun of a woman or a queer person making fun of the queer experience. And by proxy, these people are going to be better at telling these jokes, at making their audiences feel safe while talking about the taboo things that come along with being a queer person, for example. This now leaves the white men to have to think of new ways to make the benign violation theory work for them. I'm about to show you the video of the first time I ever did stand-up comedy. It is about 2 years ago to this day almost. I feel like I'm gonna barf. It's one of the cringiest things I've honestly ever seen. I've actually only been able to watch it once in my life just to like try and learn from it, and then I just couldn't again. I cannot believe I'm gonna show this to in this video. I say a lot of ums, which is like the #1 rule. It's like, don't say I'm obviously just procrastinating. This is a sad attempt at me trying to use the benign violation theory. Here you go. I actually was a closeted high school kid who had to try and date guys while sharing a landline with my parents. And so I used to go to this thing called the Homo Hop, which was like a gay party, and I would like dance and make out with guys. And sometimes they'd want to get in contact. And nothing screams being mature enough to date someone than writing like, my parents don't know the truth about me, underneath my phone number. So this isn't usually how dating works, but it was like really scary when they'd actually want to call. Every time the phone rang in my house at that time, it kind of felt like when Princess Diana died. It was like, I was scared and nervous and sad, but I didn't know if I needed to be. Okay, that was awful. That was the first time I think I'd ever really been on stage. Princess Diana dying is an unsafe situation, and I think I was trying to relate it to like my own queerness, my own vulnerability. As a young person at the time, I didn't understand why we were all so sad. I just like cried with my parents because it felt like the right thing to do. And also, in fact, scientists have found that there's a 17-day latency period between a national tragedy happening and you being able to make a good joke about it. This joke that I made was like 21 years after this tragedy, so I hope it was okay, but again, it was the first time I ever did comedy. It was essentially what I would say a bad joke, so maybe it didn't work. But how scientists figured out this latency period is exactly how they figured out what the funniest joke in the world is statistically. Known as Laugh Labs, a website was left up for a year where 1.5 million participants took part in a survey studying humor. Participants around the world would give their information over, do a survey, get fed a bunch of jokes and interesting questions about humor, sliding scale answers of how funny or unfunny they thought things were, and with all of this data, there were some pretty fascinating things that we were able to take away. The most effective jokes are 103 letters long, so all you Twitter heads out there, write that down. People seem to enjoy jokes the most at 6:03 p.m., maybe tired from the day, a little delusional, laugh, laugh, laugh. The funniest animals were ducks, which I think makes sense.
They've got corkscrew dicks.
And most fascinatingly, the joke I am about to tell you came in as the funniest joke in the world. It follows the benign violation theory quite clearly, so you might think it's really funny, or maybe your comedy sense is a bit more alt. I'm gonna read this to you like a librarian. Two hunters from New Jersey are out in the woods when one of them collapses. He doesn't seem to be breathing and his eyes are glazed over. The other guy whips out his phone and calls emergency service. He gasps, "I think my friend is dead. What should I do?" The operator says, "Calm down, I can help. First, make sure he's dead." There is a silence, then a shot is heard. Back on the phone, the guy says, "Okay, now what?" I must say, a bit too violent for my
sensitive tastes.
I find the neurophysiology and evolution of humor to be extremely fascinating, especially as someone trying to attempt stand-up comedy. But the writer E.B. White did famously say that analyzing humor is like dissecting a frog. Very few people are interested, and then the frog dies. Thank you so much to Skillshare for sponsoring this video. Now you, in the link below, you need to click that link because the first 1,000 people that do get a free Skillshare premium membership. They go fast, so make sure you click it quickly. I'm a person who loves and needs new experiences, so Skillshare for me was very important this year. I took a sci-fi creative writing course. I learned from Matt Belisai how to write creatively to make viral things work on the internet, which was really interesting, and I used those skills to make a bunch of viral TikToks, which ended up working out for us, and now we have a pretty good TikTok. Also, I became a birder this year, obsessed with birding now, and so I took a nature photography course, which helps me take better photos of the birds. It's wild because I learned all these things just through Skillshare. Honestly, it's just an amazing resource. To be honest, Skillshare has gotten me through this pandemic. It's an online learning community where there's thousands of classes that you can take if you're a creative, curious person. They teach you to explore new skills, deepen passions you already have, and make life feel a little bit more fulfilling while stuck at home. There's no ads, it's only $10 a month, but again, if you click the link in the description, the first 1,000 people will get a Skillshare premium membership for free. I also think it's an amazing gift idea for the holidays. It's something that keeps on giving. You're giving someone an experience, which is always a really great idea. So use the link in the description as well for someone else. Thank you so much for watching. Make sure you subscribed, and we'll see you next week for a new science video.
From the founder of fine grooming, King C. Gillette, a new grooming range with everything you need to treat, trim, and tame your beard. With over 100 years of grooming experience, we've got the tools to help you master your style. King C. Gillette.
Hi, I'm Alex Lopez from the Aperture program. My first experience with Internet Explorer 3 was over a dial-up connection in my suddenly popular school library. I didn't know it then.
Get ready for the muscle song, the muscle song, the muscles, the muscle song, the souls, the souls, the muscle song, the muscle song.
All right, before we get into today's song, I just want to say that yes, I do feel absolutely jacked today, but also we love making these science songs for you, and this is literally the room that we make them in, which is why we want to send a huge thank you to Google for sponsoring a portion of this video and allowing us to keep making them. Just like you want strong and healthy muscles, Google helps you have strong security and passwords online with their free password manager built into your Google account.
Do you want weak muscles? No. You also don't want a weak password, putting your private information at risk of being exposed or compromised. Do you want to memorize hundreds of complex passwords for every website that you use? No, hun. And just like every muscle is unique, every password should be too.
With Google, you can create, remember, and securely store strong passwords for all your online accounts. Anytime you're setting up a password, just use Google's recommended secure password suggestion. Not only do I panic when I have to come up with my own password, but trying to come up with your own can actually put your privacy at risk. This gets saved to your account and automatically filled next time you log in, which is very satisfying. And you can easily manage and review your many saved passwords.
I'm always very paranoid about my logins, and you can check the strength and security of your existing passwords by using Google's password checkup. It will not only give you personalized suggestions, but also make sure that your passwords have not been compromised in a data breach. It's a safer way to protect all your private information, so check it all out at passwords.google.com.
Thanks again to Google for sponsoring this part of the video, and now on to the muscle song.
See the chest, you can flex your pectoralis. Major out, minor in, so that you can press underneath on the ribs as a serratus interior for boxing fitness. Turn the neck, sternocleidomastoides here. Omohyoid, how working tandem deer. On the back, now the trapezius up here. Upper middle and inferior. Shoulders up, shoulders down. Feel the deltoids work abduction of your little arms. The biceps brachii and brachialis. Flex the elbow, looking strong. Turn around the triceps, cause extension in the shape of a horseshoe to the forearm brachioradialis. Carpi on the wrist times 2. At the carpi radialis, flexor extensor 2. The hand has many muscles that we're not going through. This is the muscle song, so sing along. 600 plus that you can trust to move you on your way. Smooth cardiac and skeletal, soft tissue changing posture, locomotion organs too. Give me abs, can't resist, rectus abdominis, tendinous, inscriptions for some definition. Shot oblique with technique to rotate and twist intercostals from the chest and ribs. The longest muscle is the sartorius, adductors longest and gracilis, tensor fascial, lat and pectineus. It's your thigh, here we cannot miss. Take a look, the quadriceps in 4 parts, rectus femoris on top, on the outside vastus lateralis, medialis near the crotch. Down below the vastus intermedius sits on the long femur. With the quad you can walk, you can run, jump, squat, extend the knee, be our dancer. This is the muscle song, so sing along. 600 plus that you can trust to move you on your way. Smooth cardiac and skeletal, soft tissue, evolutionary wonders inside. Rhomboids, retract the shoulder blades with major minor. Infraspinatus and teres make the shoulder liner. Lats are looking broader, erector spinae will make you taller. Glutes are freaking huge, the largest muscles they include the maximus, the medius, and minimus. Hamstring placement just below it. IT band, adductor, magus, biceps, femoris, or flexor, semitendinosus 2, and semimembranosus 2. Calves can flex the foot for you.
Thanks to Skillshare for
is for jumping too. Only is points down your toes, so you can put on all your clothes and cover all your muscles and move.
Thank you guys for watching. This science song is very fast, so I just wanted to say if you're finding it difficult to memorize, you can use the YouTube controls and actually slow down this video. I know a lot of people have done that for like the periodic table song and the pi song, so feel free to try that. And I also wanted to ask, what other science songs would you want us to make? What other things would be useful to memorize? Some people have been saying the amino acids or the Krebs cycle. Let me know in the comments below, and maybe we'll turn that into a science song as well. Otherwise, see you next time. Thank you so much for watching. Bye.
You may not know this, but there are actually only 2 ways that us English-speaking humans perceive time. So I'm gonna ask you a question right now so you can find out which one you are. If I tell you that Wednesday's noon meeting has been moved forward by 2 hours, do you now think that it's at 2 p.m. or at 10 a.m.? If you think the meeting is now at 2 p.m., this means you have the ego-moving perception of time. You see yourself as moving forward through time. If you think that the meeting's now at 10 a.m., this means you have the time-moving perception of time. You think that you are stagnant or static, and time is flowing through you, as if you are standing in a stream and time is the water. Here's a visual representation of what I mean. Ego-moving perspective, those who chose 2 p.m. They see themselves as moving forward through time. Time-moving perspective, those who chose 10 a.m. see themselves as static, with time moving forward through them. You may think that your answer is the obvious one. I obviously think the meeting is at 2 p.m. and I can't think of how anyone could see it any other way. But when I talked to Mitch about this, he thought it was 10 a.m. and then we realized that we see the world completely differently.
So I'm here to represent all the 10 a.m. people who have the correct answer.
And I'm here for 2 p.m. I don't really think there's a correct right or wrong answer. I'm here to just defend them. I think we can be fluid with our perception of time.
In English, we call these perceptions fictive motion, the metaphorical movement of an object through space. There technically is another way that English speakers can reference time that has nothing to do with our egos, and that's called the time reference point. So if you think about seasons, you would say winter comes before spring. In that sense, time isn't perceived in reference to us. Greg posted this question on TikTok, and it was wild to see how split it was. People unable to comprehend how other people could see it the other way, and really seeing like 10,000 votes on 2 p.m. and 10,000 votes on 10 a.m.
People were reacting, and even just immediately when I first saw someone say, oh, it's 10 a.m., I was like, duh, what? And I think that is fascinating. It's an English language issue in many ways, and yeah, I don't know. I don't think we're ever going to be able to explain or agree.
Metaphors are important because they bridge people's language and thoughts. But this all has to do with the English language. The indigenous people of Aymara have a language where they construe the past as in front of them and the future behind them. Speakers gesture to the front when they're talking about the past and to the back when they're talking about the future. But to be honest, lots of different languages perceive times in different ways and maybe don't even have this issue because their language is much more direct. It honestly reminds me of Yanni Laurel. In the fact that it must be just ambiguous enough and falling just in the space between it could be either or with enough context, with maybe one more word, everyone could be on the same page. But because of the way it's positioned, like the Yanni Laurel or the dress, it's because of the lighting. It's because of like subtle differences that leave it just in this weird zone that your brain has to sort of make a decision.
But that's an illusion. I
think this is sort of an illusion.
Time is an illusion.
Time is an illusion.
Well, oh my God. This research is fascinating because it makes you realize that although time is objectively measured, it's subjectively understood. Studies have also found that we actually switch our perspectives depending on which event we're talking about. For example, a wedding, something you're looking forward to. People are more likely to switch to the ego-moving perspective. Whereas if something's coming up that they dread, like a job interview that they're nervous about, they start to then become time-moving perspective as they fear and almost want to keep that thing that keeps getting closer and closer away from them. But we still also have to grapple with the fact that you might think the holidays are coming, whereas I'm excited to get to the holidays. Like fundamentally, I think of myself as moving through time. Whereas, okay, do you think the holidays are coming to you, or do you think that you are excited to get to them?
A bit of both, but I guess in general, I feel that they're coming, yes.
And I think that we're gonna get to them.
You're trying to say that this is an illusion because there's some fundamental underlying principle that separates people into two groups, right?
In linguistics.
But what I'm saying is that many illusions, the reason like a Yanni Laurel or the dress, where people split into two categories, there probably is some underlying fundamental perception of life or visual perception or auditory perception that puts people into two groups.
Okay, so you think that this is just similarly, it's like the language version. Oh my God.
I think so.
When you start to ask people about which one they are, you might even learn a bit about their personality because they did personality tests on people with different time perceptions. And they found that people who felt like they had personal agency, who actually felt like their life mattered, were more likely to have the ego-moving perspective, to see themselves, again, moving forward through time. Whereas other people who, through a personality test, were seen to be more fatalistic, which means that they thought events were inevitable or predetermined, were more likely to have the time-moving perspective of time.
And it feels like you're lying to me.
Yeah, and it is interesting because they have done studies where people have just gotten off airplanes and they're more likely to have the ego-moving perspective. So they've just moved viscerally through space, and therefore they're more likely to now say that they are moving through time. So it's like you can actually change people's perception, which does make me think of more of like an illusion.
So a plane is like building context around something. I've just moved, so now my brain is actually thinking in a different way. That context around like what time is maybe kind of broken down.
Yeah, they did the same study where people were moving on a train, and they were more likely to do ego-moving perspective. So wow, okay. Well, I'm right. Show this to your family and friends and find out where they're at. Find out if you perceive time differently than your loved one.
Please let us know. I want to see if it actually is split evenly 50-50.
No.
Or if way more people see one than the other. Because to me, you're lying. It's a true lie.
And
everyone must see 10 a.m.
And I'm so curious about other people's languages. I want to know if people think this is just a ridiculous concept at all.
Thank you all for watching and allowing us to just
Hi, I'm Greg.
And I'm Mitch.
And we are
ASAP Science. It's been a peculiar year.
Back in September, you probably pictured taking a prom photo, maybe something like this. Standing cheek to cheek, maybe even you've effortlessly picked up one of your close friends. But now with physical distancing measures, that photo is gonna have to be at least 72 feet wide, so scratch that.
But the fact that things are different now and it might not be a traditional graduation doesn't take away from the amazing years of school you had, and we are here to prove that using statistics and science.
Let's begin. Of the millions of people graduating around the world today, 40% are actually in China and India. So hello, international smart people.
Focusing on America, we have 1,975,000 people graduating with bachelor's degrees, 989,000 with associate's degrees, 820,000 master's degrees, and 184,000 doctorate degrees. Well, that's a lot of smart people.
About 3.7 million students are graduating from high school this year in America. And did you know, over the last 4 years, your heart beat 1,460,000 times.
It also pumped 10,950,000 liters of blood throughout your body.
So from the bottom of your heart, I think you should thank your heart.
Over the last 4 years, you and all your classmates have traveled 3,760,000,000 kilometers through space on this here planet Earth.
You produced at least 252 trillion red blood cells in the last 4 years.
Your skin sheds around 30 to 40,000 skin cells per minute. So over the last 4 years, you shed 50.8 bodies worth of skin.
Your nails grew 18.4 centimeters, and your hair grew 60 centimeters, which might be something that you've become acutely aware of in the last 3 months. 'Tis long.
You've blinked 40 million times, which means you spent 10% of your waking hours with your eyes closed.
Some of these upcoming studies only consider gender binaries. Boys
40 million times, which means you spent 10% of your waking hours with your eyes closed.
Some of these upcoming studies only consider gender binaries. Boys sleep an average of 496.4 minutes per night, whereas girls sleep an average of 507.6 minutes. That means in the last 4 years, boys, you slept around 725,000 minutes, and girls, you slept around 741,000 minutes. Of course, staying up late watching YouTube, or studying, maybe would have decreased those hours of sleep by a little bit.
This sleep was essential to develop and take care of your brain, which produced 2,044,000 new neurons in the hippocampus and burned 584,000 calories.
And did you know that while sitting quietly, your brain is actually churning through more information than the Hubble telescope has in the last 30 years? So no shade, Hubble telescope, but keep up. On average, in the last 4 years, we all cried emotional tears about 116 times.
But statistically, women cried 188 times, while men only cried 44. Now, crying actually releases the hormone oxytocin, endorphins, and can ease pain.
So boys, it's time to cry more, okay? Right now, tonight, I don't know, listen to Wonderwall, watch the movie Up, or we're all watching you graduate with the Obamas. It's emotional, okay? Let it flow. Also, did you know that the people who are graduating high school this year were likely born in 2002 and therefore were 3 years old when YouTube was invented?
We're so old.
We're so old. I know. But we're also kind of like the cool old YouTube gay science teachers, right?
Yeah, that's it.
We're the cool teachers, right? Yeah, see you. Yeah, you right there. On your phone, that's you. Tyler, put down your phone, okay? Pay attention in class. After school ended, we honestly panicked that we weren't gonna learn anymore. And so what we decided to do was create a YouTube channel about science out of our passion for science that was enriched within us by our teachers and school. So our advice to you is to figure out what it was that you were passionate about in the last 4 years at school and really pursue it.
Another reason we love science is that it can positively transform lives, and I think right now, this moment, we're all more viscerally aware of that than ever, that scientific information and knowledge is so important in keeping us safe.
So we all need to continue to listen to healthcare professionals, epidemiologists, and scientific consensus about how we move forward with this pandemic, but also even after.
Because listening to scientists means a brighter future for the human species.
Okay, so look at me. Look at me. Education is power, so never stop learning. Peace. Bye.
Brown boys, baby.
ਉਹ ਦਿਲਾਂ ਦੇ دیਵਾਨੇ ਆਣੀ ਥੋੜੇ ਮਸਤਾਨੇ ਆਣੀ ਮੇਰੀ ਸਕਸੈਸ ਪਿੱਛੇ ਦੁਨੀਆ ਦੇ ਤਾਨੇ ਆਣੀ
Brown boys, baby.
ਉਹ ਦਿਲਾਂ ਦੇ دیਵਾਨੇ ਆਣੀ ਥੋੜੇ ਮਸਤਾਨੇ ਆਣੀ ਮੇਰੀ ਸਕਸੈਸ ਪਿੱਛੇ ਦੁਨੀਆ ਦੇ ਤਾਨੇ ਆਣੀ ਪਿੱਛੇ ਆ ਕਰਾਊਡ ਮੇਰੇ ਚਿੱਤਰ ਨੂੰ ਜਾਣੇ ਆਣੀ ਕਰਦੀ ਤੂੰ ਫੋਲੋ ਉੱਤੋਂ ਹੀ ਬਹਾਨੇ ਆਣੀ ਜਿੱਥੇ ਗੱਭਰੂ ਦਾ ਜ਼ੋਰ ਚੱਲੇ ਉੱਥੇ ਨਾ ਕੋਈ ਹੋਰ ਚੱਲੇ ਪਹਿਲੇ ਨੰਬਰਾਂ 'ਚ ਯਾਰ ਤੇਰਾ ਲੱਖ ਕੀ ਕਰੋੜ ਚੱਲੇ ਗੋਲਡ ਬਰੇ ਮੁੰਡਾ ਸ਼ੇਰਾਂ ਦੀ ਨੀ ਤੋਰ ਚੱਲੇ ਗਰਾਂ ਦੀਆਂ ਆਕੜਾਂ ਨੀ ਪੈਰਾਂ ਥੱਲੇ ਪੋਰ ਚੱਲੇ ਯਾਰਾਂ ਦੀ ਹੀ ਯਾਰੀ ਸਾਨੂੰ ਜਾਣ ਤੋਂ ਪਿਆਰੀ ਸਾਨੂੰ ਛਾਤੀਆਂ ਤੇ ਫੱਟ ਸਹੇ ਕਰਦੇ ਨਾ ਸੀ all about me it's all about me all about me it's all about me ਉਹ ਸੌ ਪੁੱਤ ਜੱਟ ਦਾ ਜੇ ਲਾਡਲੀ ਸੁੱਤੀ all about me it's all about me ਉਹ ਦਿਨ ਤੇ ਹਨੇਰੇ ਕੀ ਚਾਰ ਸ਼ੁਫੇਰੇ ਕੀ ਆਪਣਾ ਜੇ ਬਣੇ ਕੋਈ ਤੇਰੇ ਤੇ ਹੈ ਮੇਰੇ ਕੀ ਉਹ ਲੋੜੀ ਉੱਤੇ ਮਿੱਠੀਏ ਨੀ ਬਦਲੇ ਨੇ ਚਿਹਰੇ ਕੀ ਕਿੱਥੋਂ ਜੱਟ ਜਿੱਡੇ ਲੈ ਆਉਣਗੇ ਨੀ ਜਿਹੜੇ ਕੀ ਸਾਡੇ ਆਪਣੇ ਹੈ ਰੂਲ ਤੇ ਹੈ ਆਪਣੇ ਕਾਨੂੰਨ ਨੀ ਸੂਰਜਾਂ ਦੇ ਅੱਗੇ ਕਦੇ ਚੜਦੇ ਨਾ ਮੂੰਹ ਨੀ ਡੱਬਾਂ ਵਿੱਚ ਅਸਲੇ ਤੇ ਗਰਮ ਆ ਖੂਨ ਨੀ ਸਿਰ ਚੜ ਬੋਲਦੇ ਹੈ ਜਦੋਂ ਵੀ ਜਨੂਨ ਨੀ ਜਿੱਥੇ ਕਿਤੇ ਵੇਖੇਂਗੀ ਕੋਈ ਸਾਥੋਂ ਵੱਧ ਨੀ all about me it's all about me all about me it's all about me ਉਹ ਚਾਰੇ ਪਾਸੇ ਪਿੱਛੇ ਆ
In the last decade or so, there's been this milk renaissance of alternatives to dairy that are exploding in popularity, from soy to almond, oat, hazelnut, coconut, rice milk, and many others. But which one should you actually be drinking if you want to be environmentally conscious?
Today we're going to go through some of the most popular milk options and rate them from worst to best based on how green they are so that you can make an informed decision when you're buying.
We've actually been wanting to start a series on this channel for a while now related to the environment and climate change and going green.
The climate crisis is going to be the biggest crisis of our time, so we want to be thinking about it and talking about it as much as possible.
Up first is plain old dairy milk. You may have heard by now, but the general consensus is that dairy milk is pretty bad for the environment. In fact, an Oxford University study in 2018 found that dairy milk results in 3 times more greenhouse gas emissions than any alternative milk and 9 times more land use. Mostly because so much feed is required for the cows and the land required to grow their feed. Dairy milk also uses the most water by a long shot, so this single glass, which is 200 milliliters of milk, would have taken 120 liters of water to make. This is even full. This is like halfway there. It's safe to say that if you're looking for an environmentally friendly milk, dairy isn't gonna be it.
Our first alternative is rice milk. Rice milk is usually much less expensive than other milk alternatives, but when it comes to emissions, it ranks very high. It's actually due to the bacteria that breed in the rice paddies, and it's because they actually release methane. Although they're not technically farting, but I mean, if it helps you understand it, then yeah, the bacteria are farting. Its large amount of fertilizers end up polluting waterways and doing damage to the environment. While some of the other crops have this runoff issue as well, making rice milk contributes 3 times the amount of fertilizer runoff compared to the other milk alternatives we're gonna get to later. In terms of water usage, it's pretty thirsty. It requires 54 liters of water per glass of milk. Thirsty is synonymous now with horny. Rice milk is not as horny as dairy milk, but it's still very horny for an alternative.
Perhaps the most popular alternative is almond milk. I feel like a lot of people have experience with almond milk. It feels like it's pretty ubiquitous to any store you go to. On the bright side, it requires smaller farmland usage than most other alternative milks, and it has lower emissions. Its main downfall is that it uses a lot of water. So this is almost a liter carton, which means it would have taken around 370 liters of water to make. To be clear, dairy milk still uses more. On top of this, the vast majority of almond farming is done in California's Central Valley, where drought potential is high, which just puts an extra strain on the environment. Not to mention, nearly 70% of commercial bees are used to pollinate almonds. And last year, a third of these bees died by the end of the season due to these pressures and environmental threats.
Next up is coconut milk. In and of itself, coconut milk has a fairly low impact on the land and low water use. You don't have to deforest the trees to make the milk, and the actual trees have a greenhouse gas benefit. Global demand of of this milk is causing some people to clear-cut rainforests in order to grow the trees for coconut milk. The vast majority of coconut milk comes from Indonesia, Philippines, tropical climates like India, and the demand of this milk does create exploitation of the worker. If you do love coconut milk, it's very important that you look for brands that are certified fair trade. I don't think I've ever really had coconut milk out of a coconut, but I know that's VVV on trend.
We did it in Costa Rica.
So I've just been alerted by the authorities that I have drank milk out of a coconut. This makes me a little bit disturbed about my own memory and my own ability to look back on my life.
Soy milk is actually a really good alternative. In the Oxford study, across all measures, it ranked really well. Low land usage, low water usage, and low emissions. As an added bonus, it's one of the only alternative milks that comes with a similar protein content to dairy milk, if that matters to you. It's soy amazing. What? Why did I turn Australian? If you say soy, it sounds like you're saying so in Australian accent. Soy. Soy. Soy, you wanna go to the garage sale, mate? I'm so stupid. Now, in the past, there's been some concern and controversy around certain hormones like phytoestrogens in soy milk, which act similar to the human hormone estrogen and have those effects in your body. But after years of research, the general consensus is that you would have to be consuming mass quantities of soy milk and tofu to see any of these negative effects. One actual pitfall of soy milk is that in a lot of places, they grow them in massive quantities in order to feed livestock for meat and dairy. And as a result, forests or rainforests like the Amazon have been clear-cut in order to make way for these farms. But doing a bit of research and reading the carton can help you find products that come from Canada or the USA and help support ethical practices.
Now we have hazelnut milk. Hazelnut milk has become more popular in recent years, and this is for good reason. It's got a nutty taste, like almond milk, and without the environmental impact. Not only do hazelnut trees pull carbon from the atmosphere and decrease greenhouse gas emissions, but they're actually pollinated by the wind and not honeybees. They also grow in moist climates where drought is less of a concern, and this creates less of an environmental strain. There are potential human rights concerns with some regions, for example, child labor being used for hazelnut milk in Turkey, so it's important that you try and figure out where your milk is coming from.
Now, before we get to our crowned alternative milk winner, there's a few other honorable mentions that don't necessarily have as much research done on them.
These include pea milk, which the producers say create only 25% the emissions of dairy.
PEA milk.
Yeah, true, not urine milk. Whoa.
There's also macadamia milk, which is a good alternative to nut milks because it uses less water and are typically grown in less water-scarce regions.
And then there's hemp milks, which are considered good for the environment because they're usually made in small batches and therefore not contributing to these monoculture mass operations that a lot of the other milks are.
It's like a microbrewery for milk. But as it stands, the current winner of the battle of the alternative milks is...
drum roll, please.
Oat milk!
That's girl pop.
After looking at all the metrics, it's the general consensus that oat milk is an amazing alternative to dairy. It uses very little water, very little land, and has low emissions. Currently, between 50 to 90% of oat production is actually used for animal feed, but the idea is that we don't have to clear cut forests for it, and over time we might be able to slowly transition or steal that production for milk as opposed to animal feed. Ultimately, there's potential to increase the production without actually causing a bigger impact right now. Oats are grown in colder climates like Canada, so they don't require the deforestation in developing countries. The main problem with oat milk is that it's a monocultural crop, which means it's more susceptible to disease in pets, and as a result requires the use of pesticides and other chemicals.
At the end of the day, the differences between these plant milks are kind of marginal compared to dairy milk, so if you are wanting to decrease your environmental impact, just choose an alternative milk.
But obviously, depending on your personal taste and dietary restrictions, you could try different ones or even rotate through different kinds, and that would be cool too. Thanks again for watching our video and our channel. Like we said, we really do want to make more videos related to environmentalism and the climate crisis. So if you have questions or want us to investigate something, let us know in the comments and we'll try and make a video about it.
And make sure you're subscribed. As always, we're still saying that. In theory, we are still YouTubers. And we will see you next week for a new science video.
See you later. Whether or not it's next week, we'll find out.
Yeah.
Being a freak is all about knowing who you are and who you can become. It's about practicing without excuses. About never giving up. Just do whatever makes you happy. No matter the score, no matter the field. Be a freak. New.
This is the only anti-aging and moisturizing cream that works according to scientists and has a scientific consensus behind it. I've been doing a lot of research on the beauty industry, including finishing this great science book about your skin, The Remarkable Life of the Skin, and I've realized there's a lot of misinformation out there about products. So we're gonna sit down with my partner Mitch, because he doesn't really know or use skin creams, to see if he can actually pick and choose which ones are more effective and teach you how to actually read the ingredients lists of these beauty products to understand from a scientific perspective which ones work. So starting in your early 20s, you lose roughly 1% of your collagen per year.
Okay, so like a lot of it's gone.
Yeah, we're in our 30s. Collagen is the protein that gives your skin strength and plumpness and things that in our society we deem as good. As this collagen disappears, that's when you get wrinkles.
I'm not that aware of wrinkles, but I feel like after this video, that's all I'm gonna think about.
I have one here and I have two here. Like I sleep on my face like this, like literally like
every morning you wake up next to me, it's literally like, you know when someone's so dehydrated, like somehow in the night you become the most dehydrated person on the planet, and you wake up with like lines everywhere, like and I'm always like, well, now you have wrinkles.
Literally trying to make a beauty video about being snatched, and you're calling out my most vulnerable part of the day. In order to understand skin cream, you must first understand the largest organ in your body, your skin. The hypodermis holds the sweat glands, fat cells, and the base of hair follicles. Next, we have the dermis, which contains collagen fibers, of which we will be talking a lot about today, and the sebaceous gland, which secretes natural oils. Next, we have the epidermis, which starts with the stratum basale right on top of the dermis, consisting of stem cells that continuously divide, creating your skin cells known as keratinocytes. Next is the stratum spinosum, where the keratinocytes link up. Then it is the stratum granulosum, where the keratinocytes flatten, lose their fats and nucleus, then reach the outermost layer of the skin, the stratum corneum, which is now the effectively dead cells at the outermost layer of your skin. The epidermis is so thin, only 1 millimeter, but it is your main barrier to the outside world. And a lot of the BS from skincare products is because this layer is actually so effective at keeping the active ingredients in creams out of your body. So I'm gonna bring out 2 creams at a time. You are gonna try and decipher which one you think is better.
I'm just trying to figure out which ones are like more BS versus which one has like maybe more legitimacy to the claims / ingredients that would actually help my skin.
Yes, exactly.
My skin, okay. That my BS detector is on.
So your first 2 creams are right here. We have the London and Grant Collagen Moisturizer. Oh my God, I've always wanted to do the beauty thing. What do they do? The London. Or the Blue Lean Revolutionary Anti-Aging Cream with Methylene Blue.
Okay, okay. Ooh, probably a sign that it's worse for you. And I've never heard of methylene blue. Oryza sativa, it's like, isn't that a strain of marijuana? Rice bran oil. My honest like evaluation, if I was to see these both and guess which is either more legit or better for you, would be this one.
Ding, 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 ding,
Is it really?
ding.
Yeah.
If you ever find a cream that has collagen in it, or a face mask with collagen in it, that you are topically applying to your skin, it's 100% BS. Collagen.
Isn't that what everything says?
A lot of things. It's actually, look at this one. Gold collagen. So there's literally flakes of gold in this. 24 karat eye cream, this is called, with collagen. There's a lot of things that claim collagen will help with wrinkles, but the molecule itself is too large to actually go through your epidermis, what we were talking about earlier, the keratinocytes. It does not get through, so anything with collagen, do not ever buy. When you read the ingredients of this methylene blue one, it has glycerin pretty high up. Glycerin is a really important molecule for moisturizing your face. It actually keeps the fluids in and on your face. So if you are looking for a moisturizer and you want a cheap one, for example, look at the ingredients list. If glycerin is high up, that will be a pretty good moisturizer. This has glycerin at ingredient number 3. This has glycerin at ingredient number like 6. Not only is it like BS with the collagen, it's not even that moisturizing. It's a much worse cream. Bye, London and Grant. Oh, we broke our floor. It's claiming anti-aging in its actual packaging from methylene blue. There's no scientific claims behind methylene blue helping with anti-aging at all. That's purely a tactic to get you to buy this. Also, not only that, but moisturizer in and of itself is not anti-aging. There's no scientific claims behind moisturizer helping with any anti-aging when it comes to wrinkles or photo-aging of your skin. So next you have the Blue Lean versus this Pure Vitamin C La Roche-Posay.
Okay, I thought it said La Croix, and I was like, they have a face cream?
So this one retails at 59 Canadian dollars. This is more expensive. This is a fancy thing.
And big writing, anti-wrinkle concentrate, renovating antioxidant. Okay, so we're
renovating?
We're going in, we're renovating the face.
Ew.
Looks like jizz.
Ew.
So it truly smells like foundation to me, like a liquid foundation.
Oh, I love the smell.
There's something about this first one that I just like really liked. And do we know like vitamin C, is that the vitamin we want in our skin? This is what these companies need to do. It should be regulated. They need to say what that is doing. I honestly think I'm gonna stick with the Blue Lean just because I liked it more, and I feel like these claims and these terms are not as clear to me, and it just seems like they're saying things that would convince someone that doesn't know.
Okay, you're right. This is still the superior cream. Good job.
Hashtag not sponsored though.
So antioxidants are something that are claimed on a lot of products that people are buying. There is not a scientific consensus that antioxidants will help with anti-aging. Topically applying, vitamin C is an antioxidant, and what is important to know is that as you read in here, the second ingredient, bran oil, also has 2 types of vitamin E in it, which are antioxidants. So this is claiming mostly only that it has vitamin C, which is an antioxidant. This cream has more moisturizing properties, and actually its second ingredient is a vitamin E antioxidant.
So it's already got what that's claiming without
without having to write it all over.
It's being subtle. It's like, I'm not gonna brag.
It's kind of funny because they're advertising this methylene blue thing, which is actually the BS part of this. So now I want to get into the idea of claims and language on this packaging. You're allowed to say a lot more misleading things on skin creams than you are on, say, food. It's just a less regulated industry. So here it says dermatologist tested for safety. Okay, so first of all, everything is tested for safety. Like, that's a weird thing that they're claiming. But if something says dermatologically tested, that just means a dermatologist had to test it. It doesn't mean that the results were saying that it was doing anything. It doesn't actually mean that, like, it's essentially a good cream. That's a really interesting sentence you can put on packaging, and it's meaningless.
I hate that.
I know, it's crazy. And clinically proven, there's no regulation on what that clinical study could be. Technically, you could make a cream. You could go to any clinic. You could test it on one person, your best friend, and then you could write clinically proven.
What?
Yes, there's no regulating body to say if something is clinically proven or not. They're not technically lying.
Sneaky.
And even here, it says a renowned antioxidant, which we now know, with something called neurosensine. And then when you look it up, it's a chemical that this company has created. And there's not really any clear information on what exactly it is. And there's definitely no clear scientific information that it does anything. Active ingredient is another important one. Active ingredient, again, it sounds really great to your ears, but that could only be in vitro, that could be in a petri dish, that could be on rats. It doesn't have to ever be on humans. Active ingredient, dermatologically tested, clinically proven, all of these things are essentially debunked. Don't allow those words to trick you. And again, we're gonna be learning how to read the ingredients list to get the best moisturizer and anti-aging cream for you. So number 3, you have the Protect and Perfect Intent.
Number 3 is number 7.
Number 7, yes, that is the brand, I guess.
Okay,
Yeah.
actually, I kind of like this branding. They're kind of similar. They're sort of simple, single tone. Now that it's out, it's like, this feels like pretty cheap. So water's not even the first one.
What's the first?
Dimethicone.
Okay, so dimethicone is essentially silicone. It's an additive to make the cream. Yeah.
It just makes it like thick.
It doesn't do anything good or bad.
Aqua. I kind of like that they said aqua instead of water.
I know.
Glycerin, okay.
Phenoxyethanol is in tons of creams. It is a preservative. A lot of these things are preservatives and additives.
So it doesn't like rot.
Exactly, preservatives so that it doesn't rot and doesn't get bacteria on it. So there's some pretty important ingredients in there.
That's what moisturizer does to my hands. That's Morris alba leaf extract.
So a lot of plant additives like aloe, honey, for example, those are natural humectants. So those are the types of ingredients that will moisturize your skin.
I see like ethyl paraben, and I know that some creams and things say like they're paraben free, so I don't know if that's like a negative against this. One ingredient is retinol palmitate, and I only know this because I've kind of heard you alluding to retinol. I don't know if it's the same as retinol as an ingredient that is good. I'm gonna try it. Such a little squeeze.
This one's only $30.
Oh, it's really coming out. Not much of a smell.
They all look like semen.
Again, this one's kind of like gluey. I actually still prefer this one because I like this kind of substance more. Like it feels more like a real cream and it doesn't have too much of a scent. But I'm gonna go with number 7.
So you chose number 7 over Blue Lean?
Yes.
Correct! You're doing so good! Interesting thing about this is that the last 2 ingredients are palmitoyl polypeptide. So these are fatty chain acids attached to proteins. And studies are now showing that they can actually go past your epidermis to your dermis and stimulate collagen creation. So those are like an interesting new sort of like cutting edge science. Cool. Not enough to really claim that much, but interesting that it's in this. This also has moisturizing properties and it has retinol palmitate, which has been proven to increase collagen, but it does thin your skin. It should only be applied at night. And it's not actually saying here how much of that ingredient is in there, which is kind of interesting and will lead to our final cream. So against our number 7 Protect and Perfect Intense Advanced, we have this SkinCeuticals Retinol 0.3% pure retinol, which is interesting because you were saying you don't know how much retinol is in here, but you do in this one.
Because I know you have this now.
Yes, I do after my research. Yeah.
It seems more simplified. It's not trying to claim so many different things. So far as I can see, refining night cream, retinol, and it's just like a very specific number. Maybe it's not claiming like, oh, to have this vitamin, but it's like, here's a product that does a single thing. And I think that's really interesting.
Retinol and retinoic acid is what we're gonna talk about right now because it is the only face cream for anti-aging that there is a scientific consensus about. This is retinol, 0.3%. This is something that you can buy over the counter. You don't need a prescription for. Retinoic acid is something you need a prescription for. So these are all derivatives of vitamin A. And this has all been proven to go through your epidermis, which we talked about earlier, to your dermis and stimulate collagen growth. It also creates new blood vessels. It creates angiogenesis in your face. So it's actually quite intense. And it's interesting because it's like, obviously the one that affects your face intensely from a biological perspective is the one that's actually doing something. If you want to, retinol you can buy right now. You could buy this product. It's quite expensive. And I think they're starting to realize they can charge a lot for this because it does technically work. So if you're in your 20s and you're already starting to lose your collagen, you could just buy this retinol 0.3%, start there. But if you want to work your way up to a stronger, more intense concentration, you do need a dermatologist. And that's because it does irritate your skin. It can create redness. And retinoic acid in and of itself is toxic when you consume it by mouth to rats. And therefore, they have actually like fallen under like regulating bodies as dangerous. That's another reason why you need to go to a dermatologist.
Thinking that it's gonna irritate my skin and make it red, make me sensitive to the sun and all these things.
Yeah, apply this. You have to apply this at night. Don't apply it during the day because you will more likely to get sunburned.
It makes me a little afraid.
Well, you kind of should be. So one thing that's important, and they make it clear on the packaging and based on the scientific evidence of this, is you need to start low. You can start it at 0.1%, start once a week, work your way up to 2 times a week, work your way up.
Why do we have that one?
I don't know. I thought I could handle it. I apply it at night with a moisturizer. That's something that they say is worth doing because it does dry out your skin. And also literal light can deactivate the retinol. Like, it's a very sensitive molecule. And it does make your skin feel weird, and it does make my red ass skin turn more red.
I'm freaked out by that.
Yeah, that's totally fair to be freaked out by it. It means you don't care also that much about this anti-aging concept.
Or I'm just anxiety ridden and scared to like do something that could potentially not be like just 100% safe.
Yeah, okay, but I mean, it's the only one that works.
Okay, wow. Well, okay, toss them all out. What I will say And this is no shade to anyone. I just want to put it out there that also there's nothing wrong with wrinkles. There's nothing wrong with not wanting them. There's nothing wrong with having them. I don't believe that there's any medical reason that wrinkles are bad.
No,
for
they're
someone.
not. They're actually quite beautiful and like indications of a wise life. Yeah, wrinkles are maybe more of like a sign of the inevitability of death.
And in this industry, it's necessary, okay? I just like start pouring.
I know
it
now,
all.
I'm like driving off. In summary, don't fall for products that claim that collagen is gonna do anything to increase collagen in your skin. It won't even get absorbed. Don't fall for sentences such as dermatologically tested, clinically proven, or active ingredients. Make sure that there's humectants high on the ingredient list, such as glycerin is a very obvious one, or natural ones like aloe and honey. If the ingredients have antioxidants, palmitoyl, polypeptides, and retinol in them, you're checking all the boxes for any scientific sort of understanding for anti-aging, but retinol is the only ingredient that is scientifically proven to be absorbed and to stimulate collagen within your skin when applied topically. That is our video, but I just want to say one more really important cream, and that is sunscreen. Because UVA radiation is actually what breaks down the collagen, so staying out of the sun is like the best.
Preventative.
technique. It's preventative. Also, really good for your skin, not drinking, not smoking, sleeping a lot, and drinking lots of water, and eating healthy. I am now sounding like your mom.
Thank you guys for watching. We hope that the beauty industry is quaking,
Yeah,
ready for
James
our
Charles, look
snap
out,
skin.
sister. Hey sisters, welcome back to my YouTube channel.
If in future videos you notice that we're looking really flawless, let us know. Otherwise, we'll see you guys next time.
You might hate me for saying this, but she's not too busy to text you back. She just doesn't want to. She doesn't want to because you're too obvious, you're too easy, you're trying too hard, and it makes you seem lame and boring, even though you were anything but. Look, I bet she seemed really into you at first, right? But then she started pulling away, didn't she? And her responses started taking longer, her texts started getting shorter, and I can't wait to see you turned into, sorry, I'm so busy right now. Let's cut the crap. You know I'm too busy is a lie, right? Everyone knows. If she really wanted you, she wouldn't be busy. She would make time for you. You want to know the real reason she pulled away and stopped talking to you? It's got nothing to do with your height, your looks, or your confidence. She pulled away because you were too easy. Too much of a sure thing. She knew she could have you anytime she wanted. And to a pretty girl, that makes you about as attractive as her brother or her gay best friend. So what are you supposed to do? I'll tell you right now. You know that girl you've been thinking about?